So go back to screen share. And of course, we can't start without a pop quiz. So who was paying attention yesterday? All right. Anybody want to volunteer for number one, or are we going to call on people?
Asco would like to volunteer for the first one.
All right.
NAR and Tripoli.
That was an easy one. All right. Number two. What are the two types of flight profiles?
Speak up.
Single deploy and dual deploy.
All right. Do we have another school that wants to try for three? What are the 6 phases of a single deploy flight profile? Daniel?
Launch, power descent, coasting flight, ejection charge, slow descent, and recovery.
Correct. All right. And what's the difference between single and dual deploy?
Right.
Say one parachute for single deploy and 2 parachutes for double deploy, dual deploy.
Frank, you accepting that?
Sure, that's good.
Should we elaborate?
No, you're good. Thank you.
All right. Another easy one. Who's the manufacturer of the kit that you guys are all building today?
The Caliper ISP by Log Precision.
Bonus points. All right. So where is the mid-centering ring located on the motor mount 2?
That looks like
Any-
5¼ inches forward of the fans.
Correct. Thanks, Daniel. You showed me a picture.
All right. And then for the last question, why were we sanding everything down yesterday? Daniel?
So I can fit a little better onto the pieces of the equipment.
It also helps the epoxy adhere better as well.
Okay.
Right. So, propulsion
Right.
overview.
Morning, everyone. So we have 3 slides on propulsion. So the first one is to talk about the sizes of motors. This one you guys are doing is an H motor, and that's the smallest size of a high power rocket motor you could do. And what qualifies motors as a high power motor is it's has more than the impulse or grams of propellant listed or uses metal parts, but it's basically big enough that you have to go through a certification in order to buy them. Anything smaller, like a G or even a D or an E motor, you could buy those at Walmart or Hobby Lobby, and you do not need a certification for those. But they break level 1, 2, and 3 into those 3 categories based on increasing complexity of what it takes to keep the rocket safe. H through J, H and I are considered level 1, and that's what you guys are certifying for by building this rocket and launching it during launch weekend or at your local site. And level 2 is J through L. As you guys are going through your challenge design, you've probably noticed that those are level 2 motors you're using for your competition rocket. And that's why, assuming that you have level 2 certification, yeah, that's why we encourage your AAA or NAR mentor to have at least this level 2 certification so they can advise you on building rockets for that. And then our AAA mentor also serves to purchase motors if you guys choose to do any launches outside of the competition, like rocket launches for your competition rocket in your home state or home region. And then once the level 3 is what FNL doesn't usually touch on, but that's like the really huge ones. M and O, those are really big motors. Like you guys motor mounts like a 38 millimeter. The level 3 motors are usually the long 54 millimeters up to 98 millimeters diameter. They're huge, and usually only the RSOs, people like Frank, are level 3 certified, because that takes a lot of more documentation and coaching and building a bigger rocket with more safety features to get certified and that to fly and buy level 3 motors. So does anyone have any questions on the 3 levels of high power rocketry in NAR and AAA so far? If not, next slide, I just want to talk about composite motors for a bit. There's a couple different types of rocketry motors. There's composite and black powder. The black powder ones are the smaller ones you would buy at Hobby Lobby, the like A through D or E motors. And they burn bottom to top, whereas composite, it's like the video shown there, that's a diagram of how it burns. It actually burns from the center outwards. And the diagram at the top, the red cap, that's the nozzle, that's the direction that the flame burns. And as you go up, there's like your nozzle app closure that keeps the nozzle on. And then the blue stuff in the middle, that's the composite propellants. The ones we usually use ammonium perchlorate composite propellants, or APCP. You might see that on the Aerotech branding. And then on the right side, that's the forward part of the motor. That's your delay grains and ejection charge. That's what deploys your parachute. The delay grains, it's a very slow burning element that it takes 14 seconds or whatever is listed on the packaging to burn, so that it pops the black powder ejection charge exactly when you need. And there are drill tools to you can drill some of that delay grain out to make it burn faster. And we'll be doing that for your motors too. I think they come as 14 seconds and they optimal is either 9 or 10 seconds. But yeah, the picture on the bottom right, that's the motor with the igniter. That's the EMATS or electrical igniter. You have to stuff that through the length of the motor. So it basically goes up to the tip, and it ignites it from the top, and it the whole center of it, of the propellant, starts burning through the length, and then it as that video shows, it goes like inside to outside. And different motors use different cross sections to get different thrust profiles. Like as you can see there, there's kind of some like 4 spaces in the middle to make it burn at different rates. That's how we get different thrust profiles. Sometimes it'll be a big kick at the beginning and then slower burning for like a total of 3 seconds, or it'll go all at once. It could go like boom and then it's over, or it could be a slow burning motor and that it's like 6 seconds, but it's very low thrust. And that's just up to the design of the motor. And oh yeah, thanks. The thrust curve graph there kind of describes that in a standardized way. It's time is on the x-axis and then thrust is on the y-axis. And that's how you can see how much thrust the motor will give throughout the length of its burn time. And important metrics we get from that is the amount of thrust throughout. If you average that, that's a standardized value we call the average thrust. And we use that to make sure our rocket is light enough for that amount of thrust to actually get it off the launch rail onto a safe velocity. And the method we use for that, it's called the thrust to weight ratio. And that's basically our motor needs to provide 5 times the thrust as the rocket weighs in order to get safely off the launch pad. So like that example, a 10-pound rocket, you need at least 50 pounds of average thrust. And we know an average thrust because there is max thrust as well. Like in the example below, there's a peak right at the beginning of the burn time and then it tapers off. So if you take the maximum thrust, that's not an accurate measurement for thrust to weight ratio. You need the average thrust throughout the whole burn time. And when you guys go to measure these in your competition rockets, they'll be in different units. You might have already realized that. Usually the motors show their thrust in newtons, and you generally deal with pounds and rock sim. So you have to make sure to convert those correctly. But yeah, thrust to weight ratio, very important. It has to be at least 5 to 1. It can be higher, 10 to 1. That's also good, but any lower, 3 to 1, that's an unsafe liftoff, and our ranges won't allow that. So it needs to be above 5 to 1. So definitely remember 5 to 1 thrust to weight ratio. Any questions on motors or thrust to weight curves?
Right.
Move on. Right.
Shall we get back to a little building?
Sound check. Okay.
Yep.
All right. Cool. Okay, we're going to dry fit the coupler into the sustainer or payload section. Make sure it's your sustainer, that's the short tube, fits inside your coupler, slides inside like this, nice and easy. If it doesn't, you can put on a 45-degree angle and kind of twist it in. If it does not fit, you can stay on the corners of your payload section, but it seems like it goes in pretty good. If one side's tough, try the other side. Okay, this nose cone, this coupler is approximately 6 inches long. This is a 3-inch rocket, and by standard, if you have a 5-inch rocket, your coupler should be 10 inches long. If you have a 4-inch rocket, your coupler should be 8 inches long. This is 6 inches long because it's a 3-inch diameter body tube. So what I want you to do is take your ruler and mark right in the center, 3 inches. I want you to make a pencil mark at the 3-inch mark. On one side, turn it 180 degrees. Do the same thing on that side. Mark it at 3 inches. And once you establish your reference of 3 inches, which is the center midway half between the coupler, I want you to put it into your sustainer like this and draw a pencil line all the way around it on that 3-inch measuring mark that you made. And look what Sean's doing, he's drawing the line. Once you establish that reference line on that coupler, you pull your coupler out. And you can mix some epoxy up, please, a very small amount. Probably a good 1 second shot into the cup with each resin and hardener. 1 second means that as soon as the epoxy hits the bottom of the cup, you can start counting 1, maybe 1.5 would be suitable. And mix it up real good with your mixing stick. Don't forget your gloves, 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 gloves. I do a 2 second squirt in there because we're going to epoxy something else right away, just in case. 2 seconds. 2 second squeeze once it hits the bottom of the cup. And mix it up. And we want to take your craft stick and we want to apply, as it shows in the picture, some epoxy a good inch inside the sustainer, all the way around. Try not to get it on the outside of it. Do not put it on your coupler, but just put it on inside the airframe. Once you've applied enough epoxy, take your coupler and your airframe, put it inside and twist it around as you put it in and stop at that halfway midpoint. And as before, you might have to squeeze it a little bit to hold it where it is. Make sure it's in that center position. You probably lay it on its side if you wish. Shouldn't run anywhere else because it's kind of sealed between the inside of the airframe and the coupler. You want to lay that off to the side. Good job, Sean. Yeah. Okay, if you have any extra epoxy left over, if you have that set off to the side, on its side, camera 2, let's see, there we go, just lay it off to the side like this. If you have any extra epoxy, take your motor tube that you have here, and I want you to put a fillet on the inside of that forward centering ring. Take some epoxy and put it on the forward part of that motor tube. Right there. I have mine taped just for a reference. That's on the forward motor mount ring, not the mid, the forward. Make sure your coupler, you're not bumping your coupler or pushing it in or out. Make sure it's sitting by itself, nice and steady, and it's that 3 inches sticking out. Once you applied your epoxy on your forward centering ring, you may want to maybe put it on a cup like so, and put it down on a spot where you're not going to bump it so that epoxy doesn't run on you, just like so. I have to wait for that to set up a little bit. Oh yeah, that's a little out of order. Go to the one before that one. Yep. Oop. Yep. We're going to give that a good 2 minutes, Rob, on that epoxy that we put on the back side of that forward centering ring, so that epoxy doesn't run and they tip it over. Shouldn't, but they should have done that last night, but no biggie. 2 minutes is 2 minutes. Has everybody applied some of that epoxy on the back side of that forward motor mount ring, centering ring? Can't see anybody. Let's see here. Yeah, there we are. Thank you. Got it. Okay, what we're going to do next, and watch out for the epoxy dripping on the back side of that forward ring, because we're going to be working near it. You're going to take your recovery cord and unwind it all. I don't know what colors you got. I got a pink one here. You might have a green one, black one, blue one. And both ends should have sewn loops on it. Take one end that has a sewn loop on it and put it through the eye bolt, like this, like so. And go to the other end of the recovery strap that has the other loop, and put the long end through the short end of that loop that you've already put through the eye. And cinch it up. What's going to happen is that sewn part is going to be going through that eye again. And you should have a good tight slip knot on there.
Can you show that one more time?
Again. Take one of your sewn ends on your recovery, sewn loops, put it through the eye. And so grab the other end of the recovery strap that has the other sewn end on it, put it through the short end of the strap through the loop, and draw it all the way through. draw that sewed on loop to tighten it up, because that sewn on part where it's sewn on by the loop is kind of stiff. You got to kind of work it through. You just pull on it tight, and it'll cinch right up just like that. Do I need to do that again? Everybody got it? Thumbs up, thumbs down. Do I need to do that example again? Or are we all good? Justin, you need it again?
Yeah, I'm probably gonna need it again.
Okay. Okay. Got your recovery strap. You have 2 loops on it, right? Take one of the loops that you have, put it through the eye of the forward motor mount ring, like that. Take the other end of the recovery strap, put it through the loop that you just put through the eye, just like that, and bring it all the way, the whole recovery strap through that loop that we just put through the eye bolt. Okay, should be like that, and you should tighten it up and draw it real tight, just like that. Yep, perfect. Good job. Yep. Okay, once you've established that, everybody have that? Thumbs up, everyone? All right, thank you. Thank you. How you doing? You doing okay there, Daniel? Okay. Okay, we're gonna leave about a good 8 or 10 inches, like so. And we're gonna end up like wrapping this up in your hand. Take a good 6 to 5 inch coil like this. Okay. Just like that, and we want some of that to hang out a little bit. And what we're gonna do is take a piece of masking tape. I should have told you to get that before. But take a piece of masking tape and wrap it around the center of that loop as best you can. Of course, I got gloves on, and it's hard to do with gloves on when you got tape that wants to fix it itself. So just kind of loop it like that. Okay. Leave about a good 8-10 inches of slack in it, and it's a good 5 or 6 inch loop you're gonna make. And once you establish that loop, when you got it taped, I'm gonna stuff it in the tube, just like this. So it should be like that, stuffed inside the tube. The reason why we do that, so when we install this motor tube inside the airframe, none of the epoxy gets on the recovery strap. Nice and safe inside the tube. This camera, that camera. This camera, that camera. Abigail, you're doing good. Justin, how you doing? Okay, thank you. MTT? Excellent, thank you. UTTC, how you doing? All right, thank you. What is that, Sean? Looks like a cat.
Yeah, it's a cat. It's my cat.
All right, cool. Daniel, William, Daniel and William, you're okay? Okay. Thank you. Jacob, cool?
Hey, Sean,
Yeah.
you got a new tat?
Uh, yes, I do.
What do you got?
My cat.
All right,
Yeah. So,
very cool.
thanks.
How you feeling?
I'm feeling like it's midnight. Yeah.
Okay, Rob, next slide. Okay, we're gonna dry fit the motor tube inside the airframe to make sure all your measurements are correct. Avoid making any burrs on your airframe. It's gonna happen, but try to avoid it. So what we're gonna do is take the forward part of the airframe, the motor tube, I mean, and we're gonna insert it in the aft end of the airframe where the fins are, and we're gonna insert it inside like so. And to get it in there nice and smooth, put it in like in a 45-degree angle like that, and kind of tip it in, slide it in, and see if you can get that center mid ring in there. If you can't, you need to sand the outer part of the motor ring on the outside. And of course, mine goes in there nice and sweet because I had practice. If it does go in, push it all the way to where the mid motor mount centering ring goes right above the fin slot. Okay? Should clear that fin slot. And to accurately know that it's going to clear that fin slot, once you get your mid centering ring in there, if you have it out a little bit like that, you can take your fin and push it in like that. It should fit in. And once you have your mid motor mount ring in position above the fin slot, your motor tube should be perfectly aligned with the aft end of your airframe. Shouldn't be sticking out. If it does, it'll still work, but it should be a good fit for the motor tube is even with the airframe. If you have a problem trying to get it in, you got to sand, sand, sand. You can twist it in if you have to. But this is just a pre-fit check, making sure that your mid-centering ring is clear of your fin slot and the end of the motor tube is equal with the airframe. Can I see everybody's airframe too in the camera? See how you got it? Thank you. All right, thank you, William. Thank you, Daniel.
Kind of like before too, if you're having a hard time getting it in, put it at the 45 right before putting it in.
Right. The mid ring is going to be the hardest one, so that one needs the sanding. And try not to burr the end of the airframe. If you have burred it too much, you can sand the airframe too on the corners, edges. Abigail looks like she's really having a hard time. Can you get it inside? Otherwise, you gotta go ahead. Abigail sanding. You can sand if you want to sand the forward part edge of the mid ring to make it a little round on that side. Go ahead to make it smooth if you have to. You can even take your craft stick too and a piece of sandpaper wrapped around it and sand like this too. At least your craft stick will take the pain of your finger away. Okay? You can get a nice stand on it and you can do the edge of that motor mount ring to make that motor mount ring have a little pivot in it so you can slide it in the airframe. And once you've established that, maybe you want to do a little sanding with your sandpaper on the inside edge corner of that airframe. And try it again. Go at a 45-degree angle, push it in, and kind of twist and turn. And take a little effort, just like that. And get it as far as it'll go to the forward part of the fin slot on that mid centering ring. And your motor mount tube should be equal with your airframe. Everybody got that? Abigail, how'd you do? How are you doing? Got it? All right. Justin?
I'm still sanding down my my mid ring right now.
Okay. United Tribe, how you doing? Did you get it inside the tube? I can't hear you. You're muted. Montana, how you doing?
Just got a little more sanding to do on that mid ring.
Okay.
And Frank in the
you
chat,
can-
Andrew said he had a lot of sanding to do.
Okay. Yeah, sand it, and you can bevel the forward part of it too, so it slides in too.
Yeah.
Yep.
Make sure you twist it when you're putting it in. It'll help get it in.
Yeah, if you've removed all that black laser burn on there, if you've got it gone, that should fit real good.
That's about where I'm at.
Oh, sorry. I didn't mean to disappoint you.
Oh, so. There we go.
All right. Push it in all the way till the mid centering ring clears the top of the fin slot. Good. Everything's even.
Good.
Excellent. You guys did good measuring jobs. Excellent. Justin, how you doing? You still sanding? Looks like you're still sanding.
Yeah, I'm still sanding.
Okay. Jacob, looks like you're doing good. Yep.
I mean, it clears it. You can start sloughing as fast as edge of the slot.
United Tribes, looks like you're doing good. Thank you. Excellent.
Hey, Burkhardt, were you guys able to get your motor mount in? Oh, cool. Excellent.
Yeah. That stick was the key. I was able to really get that black sanded off using the tongue compressor.
Right. Just a little tip too, once you get your, we're not gonna do this now, but you're gonna need a lot of sanding probably on your app. Also, we're not gonna put it in at this moment, but during the lesson, when Aaron or somebody else is talking, I want you to sand the inside and the outside, because that's the last part you put on this rocket to finish the build when we get done, and it's very difficult to get it in here lined up on the airframe and the motor mount tube. So I want you to make it especially kind of semi-loose. It doesn't have to be super snug, but so it goes in with ease. That's all. Just so if you got a little time out, you can do that. But don't do it now. We're doing something else. I'll keep reminding you during this. Just don't put it on yet. Oh, okay. What we're going to do next. If I can find my stick. It's over here. Okay, what you're going to do is take your 18-inch dowel. As shown in the picture here. You can tape a craft stick to it if you're not, but you don't have to at this time. Use the dowel itself, and I want you to measure between like 1 inch or a half an inch before the forward centering ring, motor mount ring, and the aft end of the motor tube, approximately. And I want you to make a pencil mark, just like that. So it's going to be transitioned just like this on the. Gotta go down here. We transition just like this as shown in the picture. So I want you to lay that dowel a half inch or so, or inch before the forward centering ring. And then mark it where the aft end of the tube is. We're using this for a reference. Of course, that ain't gonna work out, people. You're gonna have to put a craft stick on the end of it. Sorry. First. Tape a craft stick on the end of your 18-inch dowel. And when you put the tape on, put 2 strips of tape on it, or a wide piece of tape on it, so it doesn't wiggle, so it's nice and stiff on there. And then do the measurement, half inch before the forward centering ring, and mark it on the aft end of the motor tube. We're using this for a gauge, so when we apply epoxy to the inner part of the tube, you're a half inch before we have to stop. So when you push your motor mount tube in there, it'll create a nice fillet around the forward centering ring, between the centering ring and the airframe. The reason why we use a craft stick at the end, because it scoops up like almost like a what do you call it? A skillet, in a way. Because the brown part of the dowel does not pick up enough epoxy, so you want to scoop up a blob of epoxy, and you'll have to go inside. Once you did your reference mark, it's a good idea to put a piece of tape on that reference mark you made, like that. Make a little tag like that, because you can't see the reference mark when you're busy trying to put in epoxy inside your tube. So this way you can see that flag of that tape hit the top of your, the aft end of your airframe. And what I want you to do is mix some epoxy, a 2-second squirt. You have to lay your airframe almost level, because you don't want the epoxy dripping down the airframe either. So once you scooped up some epoxy, be careful not to drip it all over. And inside the tube, stop where your mark is or your flag on your tape and apply epoxy in the bottom of the airframe. Once you have enough epoxy on the bottom, take your stick out, get some more epoxy, rotate your airframe again, grab some more epoxy, do the bottom of the airframe again. Stop where the mark is that you have the little flag tag on there. Pull it out, rotate your airframe again, grab some more epoxy, and apply it on the bottom of the airframe like that. And if you got enough epoxy on the whole radius of the inside of the airframe, you can spread it around. We gotta do this quickly because it sets up in 2 minutes. Once you have enough epoxy inside the airframe all the way around inside by the forward ring, put your motor mount tube in and push it all the way till the mid-centering ring is on top of the fin slot.
Hello, this is Haskell. I'm
Yep.
still having trouble mark it on our stick.
Okay. Okay, you got your stick with the craft stick on it?
Yes.
Okay, what I want you to do is line up your craft stick and your dowel taped up and stop short a good ½ inch before the forward motor mount
Okay.
ring, okay? And then go back to your aft end of your motor tube and mark it right there. Mark it with a pencil. You know, as best as you can. Then take a piece of tape, like I have here, kind of make like a little flag where you can put the mark.
One
Okay.
second, I'm getting my tape.
Sure.
Okay.
The reason why I put the flag there because you can see it better when you insert it inside. You know where to stop instead of a mark. Now, like I say, grab some epoxy, scoop some epoxy up out of your cup. And be careful, and then insert it. Use your stick as a gauge, and when you get to that point where the flag is, right here at the aft end of your airframe, wipe it on the bottom of the airframe.
Okay.
Take it back up. Rotate your airframe again. Grab some more epoxy. Do the same process. Stop where that tape takes it and wipe the bottom of your airframe. Keep doing that all the way around.
Okay.
All right. Thanks.
Thank you.
Yeah, the craft stick kind of acts like a spatula, so you can get enough epoxy on it. And once you get it in, tip your spatula down, which is the craft stick, and wipe it on the bottom of the airframe. Rotate your airframe, do the same thing all the way around. Just makes it easier. Don't get that epoxy set up too quick. So once you get the epoxy around the whole airframe, I want you to put your motor mount tube assembly inside the airframe. Make sure you get that mid in there. Push it all the way to once it clears the top of the fin slot. Or you can take if you see your fin slot, if you see your mid motor mount ring inside the fin slot, you take your fin and insert your fin and push that mid motor mount ring where it'll stop once you push the fin in. It should stop right there. And kind of rotate your tube around and make sure that mid motor mount ring is clear of that fin slot all the way, all 4 fins. If you see something showing there, put your pin in and push it in so it's clear, so you can get all your fins in, but don't put all your fins in, just do one here right now. And once you've established that, you have the epoxy inside there. You should have like a nice fillet of epoxy around that forward motor mount ring, and then keep your airframe up with the pointy end up. Yep, just like that, John. Yep. Because we want the epoxy to run down onto the forward motor mount ring. How are you doing, William? Do we need to go anything? We need to go through anything again with the apply? Oh, William needs help with the measurement.
I'm just applying it right now.
Oh, you're just applying. Okay.
I just want to clarify.
Whoops. Too many speakers on. That's usually me.
We just
Go
wanted to
ahead.
ask, sorry, United Tribes here. Did we only put epoxy along the like forward motor mount area?
Yes, just the forward motor mount area inside the airframe.
Okay.
You got your stick out and you got the gauge, the distance it's supposed to be?
Yep.
Okay, yeah, just apply it to the inside of the airframe, all the way around the airframe. Yep. We're not applying any epoxy to this motor mount tube.
Okay.
Just the airframe. Because once you put your motor mount tube inside, and the epoxy you'll apply, you'll be pushing that epoxy up against the forward motor mount ring. And once you've cleared the fin slots with the mid motor mount ring, your motor mount tube should be even with your aft end of your airframe. And then keep your airframe up like this so the epoxy runs down onto the forward motor mount ring. Yep. Perfect.
Yeah. Okay. I think we're good then. Thank
All right,
you.
great. Yep.
When you end up capping up the rocket with the bottom ring, that's where you'll get the extra epoxy. That if you're wondering why you didn't put any on that middle one, that middle ring is mainly for extra support.
Right. Yeah, once we epoxy the fins in and the aft ring and all that, it's not going anywhere. Nick looks anxious. Now, Tribes, look like you're all sitting there waiting, right? Okay. William, how you doing? Okay. So everybody should have their motor mount tube inside, setting up. Excellent. Justin, you okay? Thank you. Jacob. Are we okay? Oh, we're pushing it in now. Come on, get it in there. Make sure that the mid centering ring is clear of the fin slats. Just clear the top fin slat. Daniel, how you doing? Okay. Jacob, did you get it yet? Or are you still sanding? Got it? All right. Looks like everybody's done. Next slide, please. Uh-oh, Aaron. Oh, I got this one. Okay, the motor that we will be using in RockSim will be a either 219 or H100 DMS. An H100 is usually the common one that we use. That is the W stands for white lightning. It emits a kind of a white dense smoke with a nice flame above it. The H219T stands for blue thunder. It's kind of a smokeless motor almost, and it has kind of a blue flame on it. Not too blue, but hard to see.
Yeah.
Go ahead, Aaron.
Yeah,
do
so
you-
I'll be going, oh. So I'll be going over, motors in RockSim. So if you guys are at a good stopping point, I'll ask you to fire up your RockSim program if you're able. Was it Justin, were you able to figure out your RockSim at all?
They have not gotten back to me about it.
Oh, okay.
Yeah, I sent out another follow-up before, like when I woke up this morning.
I Googled that a bit and it seems like there was no way to resolve it besides asking them. There's some things about changing their BIOS settings that seems a little dangerous to me. But so I'm gonna go ahead and throw my screen up here. So there's a couple way to add motors on RockSim. Okay, I think my screen is up now. We used to have to add them manually, but with RockSim updates in the last few years, I think they put in an import tool. So when you guys are looking at your main RockSim viewer with your Caliber ISP file pulled up, you'll go up into in the top bar, this is this prepare for launch. If you hover over it, it's called prepare for launch. And click that. You'll go to, in the make sure engine selection is chosen, and then down here, the button called choose engine. And then Frank said we're doing H100 Aerotech, so we'll just see if we can find the H100. You can either scroll down or there's a way to search, so you can filter as well. So our motor is already in here. So go ahead and select that, and then ejection delay. It defaults to plug, meaning no ejection. You can set a custom one, or I think the default is 14, but we can just put that in for now just to see how the simulation goes. So when you click OK, it puts a little brown shaded area in where the motor is. And right now, your simulation says, it should say you have a wrong size motor mount. Like you guys are dealing with 38 millimeters, it's showing a 54. So we could go ahead and change that. So if you go into select your mirror and the main airframe tube, and then motor mount tube, open that up, and then go into the database tab. So 2.14 inches is 54 millimeters. For the 38, it's you have to find the 1.52 inches. So We can go to choose from database, go down to lock precision. Part number, it should be a lock motor mount on 1.52 somewhere. Oh, right here. If we put that in, it'll put in the length that ships in. So cut that down to the one you guys have. I believe it's 17 inches. And that should be more accurate than your motor fits your motor mount tube. I did want to go over in case you guys use it in your other projects or competition rocket, if you use other motors that are not in, there's a website called Thrust Curve that it's also another database. It's kind of like Rocket Reviews, but instead of rocket kits and rocks and files, it's a bunch of those thrust curves. So actually, I had the wrong one up. You guys are using H100, but if you guys go directly to thrustcurve.org, here I can drop this in the chat if you want to follow along. But if you go there, this is the home page. Go to search motors and you can look up pretty much anything. I'd recommend using this common name filter. So the one you guys are using, it's H100. You don't need to put the letters after that, just the letter and then the number. And then it brings up a couple options. You guys, it's the single use arrow text. So click on that. And then it shows you the thrust curve like we talked about this morning. And then all sorts of details about it. Average thrust of 97 newtons. And some interesting things here. I just want to point out the H100 burns for 2.4 seconds. And it has this average thrust of 99.7 newtons. Changing the burn time can change it a lot. So I brought up some other examples just to show you. There's another H1 that's called the H550, and 550 just means there's a lot more thrust, but to make it still an H motor, that amount of propellant, they make it burn a lot faster. So this one, it's like 0.55 seconds, like a half a second. So those go quickly. That's a lot of thrust at once. So if you use something like an H550, you really need to make sure your structure is good. And at the opposite end, there's really long burning motors. The I is also a level 1, but the I65, it burns for 8 seconds. So I just want to show up an extreme example. And because of that, the average thrust is a lot lower at 87 newtons, and I is a lot bigger than H. So this is low for an I. So I just want to say that as something cool to follow up. But if Roxen did not have the H100 file, you would come to this page and you would download the simulator file. You would choose Roxen, and there's a way to import that. I won't click through the whole thing. There's this YouTube video and the slides if you guys would like that. Oh gosh, I'm checking through the chat. Daniel and Jacob, you're unable to find the H100 motor. Well, perfect. We can go through loading the H100. So the easiest way to do it right now is through Roxen. So they came out with a tool for importing rocket motors. Oh, Daniel, you found it by selecting show all. Oh, okay, actually, yeah, I'll just go through that process again in case anyone else has Daniel's issue. So when you go to prepare for launch and choose engine, if you didn't change anything, it would show the 54 meters up here. It may be still only engines that match the motor mount diameter smaller. You could go show all just to make sure you're seeing every possible one, which is what Daniel did. And then you could scroll down. It's sorted by engine code, so just go down to the H's, and it should be the first one, this H100W. Was that anyone still not able to find the H100 motor in their Roxton Prepare engine dialog? Pick up or put something in the chat if you still don't have it. Jacob, can I follow up with you? Do you still not have it yet? Oh, you found it. Awesome. Well, I'll show it just in case. Like, import. Import. So if you're on a Mac, file import engine files. And this is where you would load your file you downloaded from Roxton, or sorry, Thrust Curve. You would download that, load it in here, and then it would add it to your database in Roxton. I thought there was another, so I'll find it right now. Well, if you need to, you can reference that YouTube video. So go back to the slides real quick. So once you load that, the H100, it'll show in here in your prepare for launch dialog. So let's back to that. So once you load that, I'll just go through and complete this prepare for launch just to show you how to run a simulation. So you have the H100 here. You chose make sure there's a number here. Make sure it's not plugged. And we'll step through these tabs here. You got the single deploy. So these are the deployment events. So sustainer, you have one event. You want to deploy at apogee. That's just when it kicks your parachute out. Although you could, if you want to deploy at a different time, you can set that there. Don't touch this simulation controls. It's just the resolution of the calculations. This one is important, starting state. Sometimes they might be better now, but they used to default to 36 inches here, which is 3 feet, and that's wrong. All our launch rods or launch guides are 72 or 6 feet. So just make sure it says 72 inches there, and the launch angle, make sure it's either straight up 0, or sometimes we tilt it like 5 degrees off. You could put like 5 degrees if you want. That's just sometime if it's windy, we'll do it 5 degrees into the wind so it comes back and it's easy to recover. And the launch conditions, you can tailor this a lot. If you want to be really precise, you can put in like the actual elevation where you'll be launching of your launch site, how hot or humid it is. And this will just customize how it simulates the aerodynamics of the simulation. And the one useful one for when you do your competition reports, you want to make sure to simulate different wind conditions. So we generally don't launch above like 20 miles an hour with 15 or 20. So this is probably the worst case you would simulate for, but we can just leave it at light for now. And then, yeah, a ton of other stuff you can customize if you'd like. And then we generally don't touch the tab either. So once you have all that set, then you go to either launch or flight profile. A flight profile will run graph for you. Launch, it'll just bring you to the flight simulations tab. So it just ran the calculations, and then the results in the flight simulations tab. It shows how high it went. So not making any changes to our rock sim, it went 2,500 feet. That's pretty accurate. These rockets usually go around like 2,000 to 2,200 usually. This is how fast it went. This optimal delay, that's something Rocksim calculates. It estimates that 9.45 seconds is how long it takes to get up to apogee. So that's a good kind of rule of thumb for how much delay you want to drill out of your motor. And then velocity of launch guide departure. Yesterday I said this should be at least 52 to be fast enough off a 6-foot rail. So 58, that's plenty fast. And velocity at deployment. I'm sorry, was someone saying something?
Yeah, Frank here. Also the little parachute on the left-hand side, there's an up arrow and a down arrow inside the parachute.
Oh yeah.
So it's good when it's down and the velocity on deployment is what it says there. That's a good speed right there. I see there's like an 85 velocity on deployment. That's a little quick, but 6 or can't quite read it, 8 is real good.
Yeah,
you don't want to go any, you don't want to go any faster than probably like 40 miles an hour on deployment, because you end up getting a zipper on your rocket. And you always got to make sure the arrow is either blank or down. If it's going up, if the arrow is going up, you know it's deployed as it was ascending quite quickly. You'll get another zipper. Just for a little keynote.
Do you guys all know what a zipper rocket is?
Oh yeah.
I'm sure Frank has. I have an example here. I zippered my rocket from this workshop after 17 flights. So it lasted a long time, but yeah, zippers are bad.
Yeah, a zipper is kind of like your zipper is kind of like your fin slot, only it's at the forward end of the airframe, and it usually goes from the forward end of your airframe all the way down to almost your motor mount too.
Yeah, yeah, don't mind. Get a guinea pig. This is your same. Oh, sorry.
Oh, yeah.
This is the zipper down here. This is the same lock caliber ISP kit. My filter, but yeah, the shock cord just ripped out really fast.
That's a good one, Aaron.
Good in the opposite direction. So any questions on loading motors into Rocksim? I think that the next time we'll customize like the actual parts, like the fins, and make sure they're accurate to what you have. But for now, that's all I have for the motors.
Oh, okay.
Yeah, hopefully it'll be dry. Start working on the next section.
Oh, it should be. We're gonna see if the nose cone fits. Camera on here. Let's see if the nose cone fits, and they usually do. If you want to put your nose cone on the sustainer section here, it should fit on there quite snugly, right? If it doesn't fit, you can stand the cardboard edge on it, just do mushroom roller, it should slide in pretty good. Now, just putting the, okay. Okay, we're gonna have to punch a few holes into this shoulder of the nose cone. We haven't really described any of the parts of the rocket. Of course, this is an give nose cone part. This part here that goes inside the airframe is called the shoulder of the nose cone, right? And the back of this is kind of like a bulk plate, only one hole bolt on here to connect a recovery strap once you do a deployment with this rocket. The point of this is that we're just going to keep this on here and during flight. And what we're going to do now, we're going to install some number 8 half-inch wood screws in it. And they're your little, you should have 3 of those little tiny wood screws. You put them on your paper plate or in a cup. Or like me, they're all over the place. And they're smaller than actually they're number 4s. They're not number 8, actually. Let me show you the difference between the two. Close up. Okay, on this camera here, quick. The clamp. Okay, this is the number 4 wood screw. This is the number 8 wood screw. But we're going to use number 4, the smaller wood screw. Okay? The bigger ones are used for something else. You have 3 of them at least, everybody? They're pretty short, they're pretty small. You have a Phillips head on it.
Everyone can see Frank's second camera, right? He's showing the exact what he's talking about.
Focus there. Here we go. And there should be another wood screw that's bigger than that. It's got a bigger head on it. See that? You want to use this number 4 wood screw, not the bigger wood screw. Wood screw has a pointy end. Both have a pointy end. This is the number 8. This is the number 4, and that's what we want to use. Is the number 4 wood screw. Should be 3 of them. And what we want to do is take your awl that you have, your little pointy awl, and remove the protective covering over it. And what we want to do is take your awl. This is my awl. You have a cooler looking one. What does yours look like there, Sean? Your awl. Show them your awl. Show it all. You have an awl? There it is. Little pointy awl. So what we're going to do, we're going to pierce the airframe and the shoulder of the nose cone, like about 1 inch below the nose cone. And what we're going to do is take our awl and we're going to twist it. It's going to take a little effort. Just keep twisting it, twisting it, twisting it. Don't hurt yourself. Don't try and just, as long as you're twisting it, it should go inside between the airframe and the shoulder of the nose cone. That's going to be a little stiff once you get through. Okay? And what I want you to do, they kind of gave you a little too many of these wood screws, but we're going to put in 3. So we're going to go approximately 120 degrees from the other one and do the same thing. Pierce a hole into the airframe and the shoulder of the nose cone. Make sure your nose cone is up against the stop shoulder of it. Rotate it again, another 120 degrees. And apply a little pressure. don't hurt yourself. Just do it. Once you get into that plastic, it feels like you're not through it, but you are. So we just did a pilot hole. Pilot hole is used to pre-drill a hole, so you can take your Phillips screwdriver that comes with your kit and secure the number 4 wood screw into the airframe to the nose cone. That's so the nose cone doesn't come off during flight on recovery. Because we're not using this part, we're using the whole sustainer as a deployment section. Because we don't want to lose the nose cone. If you lose your nose cone, the certification will be a null. You got to keep all your parts together. If anybody has a screw shooter on them that's cordless, go ahead and use it if you want, but put it on number 2 for the torque. Yeah, Abigail says, yeah, I'll pull one out of my purse, right? There you go. Nice job, Sean. How's everybody else doing? We're all working on it. Y'all understand? Good. Looks like Nick's going at it. I know that little screwdriver is kind of hard to work. So once you put your awl in, maybe you want to rotate it, make the hole a little bigger so the screw goes in better, because you don't have a long-handled Phillips screwdriver like we have at the moment. You have a short one. It's kind of hard to screw that in. So if you put your awl in and kind of like circle it around in that hole, it'll make it a little bigger. I see some cameras that are off. Andrew in Kiana. The cameras work at all? I see everybody's camera off. Not everybody, but. Oh, you guys are just listening. Okay, thank you. How are you doing? Good? Thank you. You're right. Thank you. All right.
Yeah, let me.
I see the chat. Thanks. All right, everybody have their wood screws in their nose cone battened down? Pretty good? All right, thank you. Good job. William, yep, okay. Okay, this is 101 rail button alignment. The rail buttons are the guides that go on a 1010 rail guide, which is a 1-inch square rail guide that we use at the launch pad. It's usually 6 feet in length, and it's on a sturdy launch pad system. Works pretty well. Been using it for a long time. Next page, please.
Well, Frank, I was going to ask, do we also use 15-15?
Yeah, during the competition, any rocket that weighs that's getting close to 18 and plus pounds on the competition rocket, we require that you use 15-15 buttons. They're bigger. That they're made for 1.5-inch type rails. Do I have a comparison? I probably do somewhere, but I'll bring it out in a little bit.
For reference, you guys' rockets will be around 2 pounds, 2 point something.
Yeah, for these ones that you're building, but just in case for any of the teams with the heavier Moon and Mars levels.
These things are huge. Yeah, these are the ones you have now. 10-10 rail buttons that you're going to be using on your rocket. Usually 15 pounds and less are good for these type of rail buttons. You can tell the difference right here. Here are the 15-15, a lot bigger compared to the small one. More heavy duty, takes the weight. Okay, next slide, please. Okay, to align your rail buttons on your airframe, a little trick here. Take a piece of masking tape. Let me start another camera here. Spotlight me here. Good job. I want you to tear off a piece of tape that reaches past each fin slot right here, at least 2 of them here. Okay. Take your pencil and I want you to mark the inside of that fin slot, just like that. On that side, inside of this fin slot, just like this. Okay, with the reference mark. Got it? Just need just a 4-inch piece of tape. And mark the inside of each fin slot, just 2 of those, of the fin slots. Okay, once you have those reference marks established, gently take off the tape without stretching it too much. Take it off the airframe and have to twist it up. What I want you to do, fold it on the non-sticky side, fold it and meet the 2 reference lines up that you made. You should be able to see it through the tape actually. And crease it right in the middle, just like that. Okay. The 2 reference lines are lined up with each other. Make a nice crease. Okay, we're going to put it back on the same fin slot area and put it back approximately where you mark the inside fin slot, and gently put it back on. Should be pretty close to it. Try that again. That was not close. inside pin slot to an inside pin slot. There we go. Now, you'll notice where that crease is. You probably can't see it on the camera. My crease is right here. Okay. That's the middle of your airframe right there. So what you're going to do, you're going to take your pencil and mark it on your airframe. Top and bottom of the tape is fine. Just like that. Take your tape off, and that's the center of your airframe right there to mount your one airframe, one rail button. But we're not done with this. It's just a reference mark right now. Oh, I need to see everybody. Exactly what Sean's showing right there. Perfect. Thank you, Kyle. Excellent. And mark your airframe, everyone, where the crease is on the tape. Justin, how you doing? Okay, excellent. Got it. Justin, thank you. Nick, it looks like you're done. Montana, looks like you're done. Okay. On to the next procedure here. Bear with me. I got to move some stuff here so I can show you what I'm going to be doing next here. Okay, if you have a door jamb in your room, that works the best for a straight edge. Turn on to the camera, Rob. There you go. Thank you. Okay, if you have a some kind of straight edge, sometimes you can use the bottom of a counter, like so, and line up your reference mark against that counter edge. You can use that for a straight line, or the best that I've always used is a door jamb stop. I'm gonna need a headset here. Okay. Okay, here's a door stop on by a door. Okay, got this part right here is a door stop. The straightest thing in the universe, just about. Take your reference mark that you've made. Okay, I don't know if you can see that. Here's the reference mark that you made right here. I got a light on it right here. Make sure that the airframe is against the door stop. Just the way you see it, like this. And line up your mark against the door stop like this, close as you can. Then start from the top. Make sure your airframe is flush with the door stop. And your bottom reference mark is up against the door stop, right on the edge corner. And start from the top. And draw a line down with a pencil. And you should have a nice straight. I'm a little bit off on my marks. So you can draw that again. And do it again. There we go. Okay. If it's off by a little bit, eighth of an inch, no biggie. But we need to make that line perfectly straight down the airframe, which you can see. You only need to make it like 3/4 the length of that tube, all the way down to the end, the aft end. Nice job, Sean. Excellent. Or you can use the edge of actually a window frame, the molding. Sometimes that's not very straight, but it's better than nothing. But right here, I'm using the end of my workbench tabletop, and pretty close. First thing you do before you put on your fin is to line that up, because if you have fins on your rocket, you can't get it up against the straight edge. You can use if it's too late and you already put your fins on your rocket, or you can't get your rocket up against a straight edge of some type, you can use this is a short piece, angle iron you can use to line up on that reference mark. It'll be a longer piece, of course. I've used a laser pen, taped it to the aft end of the reference mark, and make it right along the airframe. That works. I've used string with a chalk string on it, and snap the chalk line on the airframe to make it nice and straight. All kinds of ways to do it. All right. Does everybody have that reference mark on your rail buttons, Mark? Thumbs up. Thank you.
I
All right.
don't. I'm on.
Who's don't?
Me.
Daniel? Okay.
I think I might
you,
have missed that.
Did you miss it?
Yeah, I think I might have.
Okay. Sean, you want to show him what you did there? Or just spotlight him, Rob. You have your reference mark, right? Daniel, you have your reference mark?
For the buttons?
Yes.
No, I do not have them right now. Not mine.
Did you use the tape?
Can we? Is it possible we can go back and do that first?
Yep.
3 parts real quick.
Yeah,
I got the
I'll
line going up and down, but I don't.
Do you have the reference mark on your airframe or not at all?
I got my reference marks on my airframe for the line.
All right,
Yes.
okay, and Sean will show you how to do it on the door frame then. You have a door frame in the room?
Oh, I see. You know, I'm sorry, I got the, so those are the marks for these, right? The buttons?
Yes,
Okay, never mind. We're good.
you do have your reference marked, right? The center between the two pins? Okay, great.
My apology, I misunderstood.
No problem. Okay. No problem. If anybody else has any questions where we're at, please speak now. We don't want you to fall behind. All right. And there's one step we forgot to do with the all when we put the nose cone on. We need to make a vent pressure hole in both airframe cavities. This will equalize as your rocket ascends quickly. You want to have the pressure equalized inside the tube as on the outside air as the rocket ascends, because pressure does change as the rocket goes up quickly. And what could happen is that your rocket could prematurely separate before it gets to a slow down velocity to deploy. So we don't want that to happen, otherwise you end up with one of Aaron's zippers. So what we have to do, we have to punch a hole, and usually it's required a good 1/8 inch hole, but the alls can do this. Make your hole using your awl, and in the sustainer section, just make it right in the middle, in between, or you can go right below the shoulder of the nose cone and make a hole. It will be real easy to punch that hole because you're not going through that shoulder and nose cone anymore. And just make a small hole like that. That's in the sustainer section. And I want you to do the same thing on the booster section. You'll have to note where your motor mount tube is. We don't want to punch a hole where your motor mount tube. You want to go above the forward motor mount ring, or just above the motor tube in that open cavity of the airframe. So you want to punch another hole in there. It doesn't matter where it goes along the either along the rail button reference mark, or you can go over to the next section of the between the fins and punch another hole to make another air vent hole. Because if you noticed when you were putting on your nose cone before, everything is sealed up, you felt a little pressure when you had your nose cone put on. And that's what we're talking about, the pressure, because it changes a lot once you get past 200 feet at a quick velocity. They already got their vent holes punched through in the airframe. Thank you. Okay, next slide, please. I got a mess here.
Got this one, and then we're a little ahead of schedule.
Are we ahead?
A little bit.
Okay, cool. By how much? 10 minutes or so?
Lunch was scheduled for 12:30, so we're just about 30 minutes ahead.
Oh, well, maybe this will work if we can mix them apart. This is an important part that we missed, kind of.
Okay.
We need to mix some epoxy And we need to make a fillet on the bulk plate. On this bulk plate here, we need to mix some epoxy, another 2-second squirt, and your craft stick, and make a nice even epoxy around the bulk plate. This is the most important spot to apply your epoxy. This is a point where it pulls a lot once it deploys. So we need to put a nice thick bead of epoxy inside there. Do not get any epoxy in the outside coupler. And once you've applied the epoxy and you think you got it covered real good, take your airframe and set it up on the top like this, or some way that it positions itself like this so the epoxy stays where it's supposed to. If you lay it on its side, the epoxy is going to run. So apply some epoxy, use your airframe that you have to stand up like that. Make sure it ain't going to fall over, and let the epoxy set up, and then we can all go to lunch. Don't forget your gloves. Gloves, and your hands get sweaty. When you do use epoxy, if you use it a lot, we're not using it a lot on this build, but I've known some people that refuse to use gloves during the epoxy, and they would actually use their fingers as the mixing stick or the application. They thought they were real, nifty about it, and they ended up with, but they exceeded the amount of epoxy and built quite a few rockets. They ended up with blood poison. That's about with any kind of chemical. If you abuse it and use it a lot. Yeah, thank you, Rob. Nice picture. There you go. We found it.
Some slides we shifted yesterday. I guess we didn't finish the epoxy part.
Right. Try not to get any epoxy outside of that coupler. If you do, please wipe with alcohol wipes. Appreciate it before it sets up.
And this is one of the bigger chances of failure, is not having enough epoxy here to make sure it's secure.
Right. That is one of your load points right there, besides the eye. you all get that done, set your rocket vertical like that. Let it set up. You guys can go eat lunch.
Well, actually, Connie, did you want to interject here?
I did. I'm just gonna bring up the TRA and NAR memberships again. So I do know from, let's see, Jacob and Daniel from Pembroke. I don't have your applications yet, so if you already are members, I need your number or I need your application either for TRA or NAR. Andrew and Pequot, I have 2 memberships for both of you guys, and so if you guys could just let me know which one you want me to pay for. And then Scott, I still need yours as well. I think I'm set with everybody else. Lunch break is a half an hour, Kiana. Do you want to extend it or do you want to keep things rolling, Rob?
I would say let's aim for coming back around 12:30.
I'm for that. 4:30-ish.
Yeah, I know
12:30.
lunch will be tricky for some people, but just as close as possible.
Yep. Good job, everyone. You got done a little early. Excellent.
We will resume recording. All right, welcome back, everyone. I hope you all had an enjoyable lunch. And of course, no class would be complete without a pop quiz. So, who can name the parts of a rocket?
Okay, people.
Come on.
What's this part here called? What goes in there?
Don't make us call on someone.
That's the motor mount.
That's good enough for me. And what are these called that are on the motor tube? This wood part.
Centering rings.
Yes, very good. And what's this little cord that you put in the tube? What is that called?
The harness?
Very good. What's this section called?
Booster section.
Yes, sir. And what's this whole part called?
The sustainer.
Yes. On to the next question. Beautiful.
All right, where should the mid-centering ring be installed inside of the airframe?
Just above the fin cutouts.
Perfect. All right, and then what makes up the aft portion? We went through most of those parts.
Yeah, we did.
All right, so we'll skip that one. What's the minimum thrust to weight ratio that is required for your rockets?
5-to-1.
5 to
Good
Very
job.
good.
So now on to those fun fins.
Oh, good.
Now
We get to
in the
name them.
I'll say in the back of the handbooks that were sent out, we had an extra little sheet protector. There's a fin alignment guide in there, so that'll be handy for this. There's an extra one that's in the book itself. The one that's in the sheet protector should be zoomed in a little bit more, so it should be easier for you guys to use when actually like using it as a guide.
Okay, let me go through the parts of the fin for you. This is very important. This will be on the rock sim. You have your fin right here. This bottom part here is called the tang, or I usually kind of call it the tab, but everybody wants to call it the tang. This part here is called the root of the fin. This is the part that comes in contact with the airframe. We call that the root of the fin. This part here, from point A to point B, it's got to be a true 90 degree is the measurement, not the angle. The true 90 degree right angle to it is called a semi-span. Call it semi-span because the other side of the rocket has the other span, so we call it a semi-span. This part here is called a tip cord, I believe. That's the difference between the semi-span and the leading edge. This is called the leading edge of the fin. Sometimes there'll be an airfoil that will be pivoted into the fin here for a little more aerodynamic features, if you wish. So we got the tang, the root, the semi-span, the tip cord, and the leading edge. If I get corrected. Okay, what we're going to do, we're going to pre-fit our fins in our booster. We're going to take our fins and put all 4 of them in your booster. And each one of them, when you install them, make sure that the root of the leading edge of the fin is touching the airframe. So is the back of the root touching the airframe too. So at the same time, the tang should be, oops, I don't even have my motor tube in there, do I? Maybe. The tang should be touching the, I don't have my rim glued like you guys have, should be touching the motor tube or pretty close to it. That's where we're going to be applying epoxy later on here. So take all your fins, put all 4 in the fin slots, make sure everything lines up properly. Everything is touching the airframe and the motor mount tube.
Hey, Frank, did we do the rail buttons?
Just the alignment, yes.
Okay, okay.
Line up your fins with the crosshairs on the template you have, and they should be pretty close. There should be no movement on it. Your fins shouldn't be warped too bad. The way to look at it lined up, you should have it actually on the floor. I don't know what kind of floor surface you have. If you have a hard surface or if you have a carpet, maybe you want to tape your template down to the floor because we're going to be applying epoxy with this and keeping and lining up the crosshairs with the fins. And you get a best view when you look from the top of your rocket. And I shall show you in a second. We're better off looking at it exactly. Straight on like this from an eagle's eye view. Making sure everything's lined up properly the way it should be. Make sure your fins aren't warped. So this is what we're going to do after we apply epoxy to the tang of the edge of the tang. We're going to put the fins in and just set them for now and tack them on. The reason why we're just tacking them on is because they might move on you and you can readjust them again. You have to.
And Frank, if they needed to, if it's not flush, would sanding help make sure that comes down a little bit?
Sure. But if they're off, if they're just fraction of a hair off the motor mount tube, you just apply epoxy. It'll bridge across there and be strong enough and proper. But if it's like, you know, a good 1/8 of an inch gap in there, yeah, they may have to sand the root of the fin. But that usually doesn't happen too much. Is someone suggesting that? Okay, what slide are we on next there, Rob, after this? Okay. Sean and rocket builders, put your gloves on. We're gonna mix a little epoxy. And we're gonna do another 2-second squeeze. That's a 2-second squeeze from the time the epoxy hits the bottom of the cup. Count 1, 2, release, and mix your epoxy. And what we're gonna do is apply epoxy to the end of the tang only. Nothing else, not the root, not the back of the root, but just on the tang, on the tip right, on the edge of the wood right here. I call this buttering it up. Just like you do in masonry, you butter up a brick with mortar, or we're going to be using epoxy on the edge here. And just dab, you know, don't put a ton on there where it's dripping, just put some on there on the edge so it's on there, and immediately snap it in place on your rocket, okay? I take all your fins out so you can manipulate adding the epoxy to your fins. And once you have the epoxy on the end of your tang, put them in like that, and they should be up against the motor mount tube. Then we're going to put it down onto the template, and we're going to make sure every fin is lined up with a crosshair. If you cannot line up the crosshair, take a piece of tape. I think I have a picture of that somewhere. Yeah, take a piece of tape. Yep, thank you. Take a piece of tape and put it on the fin and the airframe and adjust the tape to line up with the crosshair. And always look at it above the forward part of the airframe. And make sure your airframe is in the center of that circle too. Make sure you see a black mark all the way around, or part of that image of that diameter. Usually that epoxy sets up in a matter of two minutes. You can kind of shift the fins around if they need to be moved without using the tape. But if using the tape helps, you may use the tape to straighten out the fin onto the crosshairs. Line them up with the crosshairs. I've got one fin that's giving me a little trouble, so I'm going to use a little tape on it. Keep it where it's at. And make sure that the root fin is, the forward part of the root fin is touching the it's touching the airframe here. There might be a little hairline gap in there. That's no big deal, but make sure it's not like sitting out like that. That's a no-no. Just like you see in that bottom picture right there. Make sure the forward root of the fin is touching the airframe as close as possible. If it's just off by a hair, or there's a little hairline in there, that's okay. As long as some of it's, most of it's in contact with it. If the back one is off, like this one is, I have a little hairline opening right there, that's no big deal. I just don't want the fin to be cocked open like that, so it's off like you see in that picture, the lower picture where it's got the red X. That's the no-no.
That's strange.
And they're pretty much touching the surface of the airframe, the root is. That's why we pre-fitted before, so if we need any adjustments, we could sand the fin, but I didn't hear any complaints. Keep looking at your fins and making sure that they're lined up with the crosshairs. Sometimes when you stop looking at it and look at something else, you come back to it, you go, oh, it moved on me. If it's off by a half a line, no big deal. If it's shaded on half a line, no big deal. Get as close as you can. Perfect makes precision, of course. Okay, where's the class at? There's 5.
Just a little bit of warpage in one of the fins. Can they tolerate some of that?
Yeah, they can tolerate some warpage. If a little bit's okay. If you're really concerned about it, when you're all done with the rocket, you can spray some water on it and take 2 boards and clamp them together and keep it overnight.
Yeah, that makes sense.
Are we on to the next slide with Aaron while this sets up?
All right, so I'll be talking about stability in rockets. This is the entire purpose of why we simulate the rockets, is so Roxanne can calculate how stable it is. So the 2 main values it uses are center of gravity and center of pressure. So center of gravity, that's kind of self-explanatory. That's if you were just to balance the rocket on like a string or on your finger in the middle, that's where the point at which it would balance out. And we usually mark that as that crosshairs, that CG symbol down in the figure. And center of pressure, that's a little harder to imagine, but it's like taking if you were to take the cross section of the area up and down, kind of like it's showing on that figure, the fins have more area, and that area that the wind would hit during flight and the nose cone has like a little less area that the wind would hit. So center of pressure essentially kind of takes the average of that, the area that air would hit, and takes an average of that, and that's the center of pressure. It's like the point at which all aerodynamic forces act on. So those 2 points are where the mass of the rocket and the aerodynamic force the rocket act on, and the way we relate them is called the stability margin. That's the distance between the CP and the CG, and the optimal distance, the CG should be ideally 1 body tube length forward of the CP. And if you do outside of that, if it's greater than 1 body tube length, or caliber, we call that, like greater than 2 calibers, say the CG and CP are really far apart and the CG is still forward, that the rocket will still fly. It would just be more susceptible to wind changes. We call that weather cocking. If the wind pushes the rocket over and it starts flying to one side, it'll keep flying to one side horizontal. Whereas if you have a stability margin between 1 and 2, or around 1, when wind acts on it and tries to make the rocket go sideways, the rocket will innately want to correct itself to go straight up. And then if the stability margin is less than 1, like in the decimal places, or even negative, that's just, we call that unstable. It won't even achieve straight flight off the rail. It'll just tumble every which place, and your fins are not designed correctly. So unstable or less than 1 caliber is definitely worse than overstable or over 2 calibers. Our kits today will be slightly overstable, and that's okay for these kits because they're tried and true designs, have been flown for probably like 40 years or so. But if you're designing your own rocket, ideally aim for between 1 and 2 calibers of stability margin. Any questions on stability and how to interpret it or what they mean?
All right.
What was that calculation for stability margin? That was the.
Oh yeah, it's measured in lengths of body tube.
Which are the diameter or the full length of the body tube?
Oh, sorry, diameter, you're correct.
Okay.
So like to you guys, it's like a 3-inch tube, so 3 inches would be 1 caliber.
3.1 inches.
3.1 inches, yeah. And in your handbooks, if you follow that reference on the slide, there's better calculations. It shows like equations you can use to calculate them based on measurement CP and CG. You're interested. Page 27.
Hey.
Okay, we're gonna get messy now. This is the most tedious part of the build. So what we're gonna do, put this camera on. What we're gonna do, as noted in the drawing, we're gonna be taping I'm gonna use blue tape just in case, so just so you can see for clarity. we're gonna tape off sections of the tube so we don't get any epoxy inside the motor tube and inside the airframe. Because we do not want to get any epoxy inside the airframe, the motor tube, or on the inside of the airframe, because we have to put this on later and push it in until it touches the tangs of the fin. So it has to go in a good half an inch in there. So we don't want to get any epoxy inside this airframe or inside the motor tube. Otherwise, the motor will not fit. And any epoxy that's in there of any type, even if it's just a little nick of epoxy, the motor and the tube have no tolerance. It has to be totally clean and clear of any foreign objects like epoxy. So what I want you to do is put some tape as pictured in the example inside the motor tube. Actually, you have to take a small section of it actually. And you can kind of curl it over if you need to, like this. Now, I do not want you to work on this rocket with the rocket laying on the table, because if you got it laying on the table, you're going to end up going like this with the fins. They're gonna rest like this. You have to let the rocket hang over the edge of the table, so there's nothing supporting the fins. Otherwise, they will move on you and they'll spread out like this. So you have to have the rocket hanging out. Put a piece of tape on the airframe part over the airframe and onto the table if you have to, or put a book or some kind of weight to hold it down right here on the table if you have to. Tape, big long piece of tape, 2-foot piece of tape would work fine. You got plenty of tape with you. Make sure you don't get any on the outside of the motor tube or inside the motor tube, next to the edge. We want the epoxy to stay. I did a real sloppy tape job. I'm sure everybody else will do better than me. But what we want to do when we have it all taped up and blocked from any epoxy interfering, what we want to do is apply some epoxy. You may have to take maybe probably two craft sticks together like this and tape them together to get in there. You can use your 18-inch dowel if you need to, but I don't want you poking out your neighbor either. But the two craft sticks work good. And mix some epoxy, the 2-second squirt, and put epoxy between the tang of the fin and the motor tube on the outside like that. All the way from the tang to the forward tang to the rear tang. That's all you need. And keep it the fin's got to be at that 45-degree angle so the valley puddles into that area as you see in the bottom drawing right there. In fact, we'll cut it again. As you can see here, I don't know if you can see that real good, but here's the tang of the fin. Here's your aft which you don't have in right now, no big deal. Here's the middle, the mid centering ring. So I want you to apply epoxy all the way from the mid centering ring on that tang all the way down to the next tang, or the end of that tang, just like that. No, that's not a zippered rocket. I did that with a table saw. So just mix one batch, enough to do the two tangs that are connected to the, that are touching the motor mount tube. Let it set for 2 minutes because we want it to set up so it doesn't run. And if possible, take your, I'd leave it on there. Because once you get 1, 2, 3, 4, 5, 6, 7, 8 sides done, you have to remove the tape right away. Otherwise, that epoxy will adhere to the tape, and it's kind of hard to take off. So what you want to do is take it off with a knife, kind of peel it off if you have to. A knife, use your knife as a spatula to take them off. Take the tape off because it's going to get kind of set up. So do this. So you're going to do 1, 2, 3, 4 sides. You're going to turn the rocket 4 ways here. So wait for that epoxy to set up till it's kind of like sticky so it doesn't run. And rotate your rocket again. Make sure you hang it over the edge of the table. Do the same thing. Get 2 fins at a time. Most important, do not rest your rocket on the table, otherwise your fins are gonna spread like this until the epoxy really sets up. If you think you made too much epoxy for that first application, you can make a little less, so you can be diligent on using the epoxy. You get an idea how much you have to use then. How you doing, Justin? Okay. We're waiting for it to cure. Okay, thank you. Now, I don't know how many craft sticks you're going to have. It's probably a good idea to probably wipe the stick you just got done using and just wipe it clean. Doesn't have to be perfectly clean, but get the lumps out of it after you get done using it. You can use that stick again, just to be a little more efficient on using all your craft sticks. And you take your alcohol wipe and wipe it clean, totally clean with the alcohol wipe. You can reuse that stick if you have to. This is the part where elevator music ought to be kicking in.
Aaron, it looked like the next slide was potentially going over fins in rock sim. You potentially wanted to cover a little of that while they're.
Yeah, I could talk about that. Yeah, if you guys are still working, you don't need to fire up your rocks and you could just watch. But yeah, the few things I wanted to go over were, yeah, putting fins in Roxim and making sure your other part sizes are correct. All right, so actually the first thing I wanted to review from the motor loading, I did find the other tool to load motors, their new feature. It's called reload engine data. And it's a tool that appeared called download engine data. I think it's just a shell for thrust curve, because if you put like H100 in there and start the search, it'll search, and it came up with 4 matches. So in case like this one wasn't in there, you could select that. And then you would click download selected engine data and it would add it to your local Roxen database. So that's a good feature to be aware of. Just cancel out of that. So for the fins, like Frank was talking about, we talked about the tip cord, this leading edge up here, this trailing edge, semi-span is this perpendicular length, and the sweep values are a little confusing, but we figured this out last time. The sweep length is this the other leg of the right triangle from the the line that you measure the semi-span from, and then the sweep angle is this angle up here. So when you go to edit your fins, so you go to your rocket design components, and then your components list, find fin set. Open that up. You guys have 4 fins, so that's correct. And then I believe if someone is done or has a ruler available, could you confirm that the root chord is actually 8.5 inches? I believe that's true. But just to demonstrate, if you were to change that, you can see that it's changing the root chord, and that's just a confirmation of what you're actually doing there. So I'll change that back to 8.5. The tip chord is this little one up here. It's saying it's an inch. I seem to remember it's 1.5 inch, but we'll leave it at 1 inch for now. But if we were to change it, you could see it's that one up there.
Yeah, it's measures 1.5.
Oh, it is 1.5. Okay. So we changed that to 1.5. And the root chord is 8.5, and the semi-span, this length here, I think it is 3.5. I remember
Yes,
that
it is.
last time.
Yep.
It is,
Yeah,
okay.
3.5.
And then could someone measure the sweep length? I'll show it again. It's this length down here from the perpendicular point of the semi-span up to the forward tip. Should be something around 7 inches.
I got 7 1/4.
7 1/4.
Yeah.
Let's see if that makes sense. Is the
7
8?
5/16 to be exact. I don't know what that is.
7.331.
There you go. Perfect.
Yeah, we'll leave it at something like that. Maybe like 6.5. Yeah, that's close enough. I mean, you guys can tweak that on your own. And then location should be accurate, but just in case you would, this controls like where along the body tube it is, but back to this. And you could do it from the like 0 from the base of the too. It's a way to do it like that. And then the thickness, I think it's, you guys are an 1/8 of an inch.
Quarter inch fin.
Oh, 1/4 inch. Oh, wow. Okay. So 0.25 thickness. And then, yeah.
Excuse me. Yeah, it is. You're right. It is an 1/8 inch only.
Oh, it is 1/8. Okay.
Yeah, I'm thinking of the ring. That's what I was thinking. With a 1/4 inch.
And then this cross section. This just changes the aerodynamics of the simulation, whereas like if you rounded it, it's less drag. And I assume most of you guys will be doing your squares. You could change that. And gloss, that means if you like put a primer and paint over it and polished it, or not polished, that's polished. Painted. Matte's just like a one spray of spray paint, and it's still kind of rough or unfinished as if you were to do nothing to it. So I'm just gonna leave that for now. There is databases here, but we already tweaked the size there. radial position. We'll use this more for the rail buttons later on, but in this view down here, you can change to an aft view. Like you're looking from the bottom up, and if you were to change this radial angle, it would just change the angle at which the fins are positioned, but we'll just leave that at 0 for now. And the last thing, oh, go ahead.
Anybody have any questions on this procedure we're doing on the boxing the fins? Okay, keep at her. Thanks.
Okay. This TTW stands for through the wall. That's what you guys are doing. It's through the wall fin mount. But as you remember, this kit was originally with the 54mm motor mount. We changed it to 38mm. So this tab or tang depth is incorrect as of now. You can see there's a little gap down there. So to correct that, Roxton makes it easy to just press this calculate fin tab depth for me, and it'll lengthen the tabs to what you need. So just make sure you do that. You want to be correct. And that's it for the fins. I just wanted to go over some other components to make this a little more accurate. So right now there's only 2 centering rings, but you guys have 3 centering rings, so we can modify those. So right now we have forward and aft. So aft is good, but Frank said they were 1/4 inch, so I'll just change that to 1/4 inch and leave the rest as is, and it's flush with the bottom of the fin tang. The forward one, I'll make that the actual forward, and then we'll add a separate mid centering ring. So I'll change that to 1/4 inch. Then I'll move that up to 1/4 inch from the top of the motor mount. Something like that. That's close enough. And then to add a 3rd centering ring, you need to select the parent part. So select this main airframe tube, and then go over to your add new components, click centering ring. It'll bring up this dialog, and I think Lock Precision has a part number for this, so we'll go ahead and find it. So scroll down to Lock Precision, and it's a 3-inch tube on the outside and a 1.52-inch motor mount. So this is the one you want, 3-inch to 1.52-inch. So add one of those. Oh, it's the incorrect thickness. Well, let's go ahead and change that. Frank said there, 1/4 inch. And this is your mid centering ring. So name it that if you want. And then the location, top of the fin tab, fin tang. So you could just drag it down to there. Just like that. So that's the centering rings. Other things we can do, we can make sure the body tubes are the right length. So we could check this main airframe tube. Is everyone 34 inches? And if anyone has their ruler handy. Oh, thank you, Daniel. Yeah, so 34 looks good. And then the payload section airframe we have is 14. I think that's right. I'm more worried about boosters, so.
Yeah, it's 14.
14, okay. That's... And then other things we could do is, you guys have been adding a lot of epoxy, and that mass is not necessarily accounted for in any of these. So what I've done in previous years simulations is adding a mass object, and that's an option over here. You just go over to add new components in the top right. It's a mass object, and they have some example ones you could add. You can even add individual screws if you like, if you want to get that detailed, or these are altimeters, stuff like that. But I'm just gonna cancel out of that and add a epoxy mass for your fins. I'm just gonna overestimate. I think the bottles we sent you are 4.5 ounces each, and I'm gonna assume you used about half of that total. So I'm gonna put 4.5 ounces in here, and then it shows us this M in parentheses down here, and then I'm just gonna locate it in the center of the two centering, the center of the fins down there. And then, oh, I'll just point this out. This mass override is on. That's because we put in a custom mass. There's nothing to calculate for the program to calculate. We added a custom mass. So it is using mass override for this specific component, but not the rocket overall. Other things you could tweak are the parachute shot cord. If you'd like, you could verify that the diameter is correct. You guys do have a 36. I know that for a fact, but like the amount of shroud lines over here, like if you happen to have 12, you could change that, or the material, and then that would go into your flight simulation results for how fast your rocket goes down.
Yeah, Aaron, you want to go to rocket, the tab, rocket design attribute? And
Yeah.
go over to, yeah, slide view marker. It's the one that says, yeah, put the like 0.800. And see, it makes your mass and your parachute, all your identifiable parts that you add to your rocket more clarity.
Yeah, that's great. And then the last thing I wanted to talk about is the stability here. So right now, down here, it says you're overstable, but that's because we haven't added the motor yet. So I'm just gonna go ahead and re-add that motor. It's the H100. Once you add that, it makes it a little better at 3.5. That's still over 2 calibers, but it's a little better. But if you guys remember these symbols, this crosshairs in blue, that's the center of gravity, and this red target symbol is the center of pressure. And the length of that, the distance between that in terms of body diameter, body tube diameters is 3.54 right now. So a little higher than should be, but it's acceptable.
The more bigger margin, the more your rocket will wind cock. If there's a a wind, like 10 plus miles an hour, your rocket will wind cock. Not that it'll be doing somersaults or anything, but the only way your rocket will do somersaults or cartwheels is if your center of pressure and your center of gravity are equal or ahead of each other. That's a no-no. That's real bad.
Actually, I could demonstrate a way you could make a negative center of
There you go.
gravity. You could put a ton of mass below, like if you add a pound mass object or something crazy like that. Located it like way below the center of pressure. Like say you put a really, really heavy boat tail on the bottom of your motor. Something like that. Well, actually that made it good. It's dramatic just for demonstration purposes. So something like that, that brings the center of gravity below your center pressure, and then now your stability or static margin is negative, which is not good. That would be a terrible flight.
Yeah, cartwheel or a land shark?
Oh, sorry, what was that?
It'd be a land shark or cartwheeling,
Oh, yes.
skywriting.
But let's delete that for now. But even your fins, like if you were to design a longer fin, or sorry, just a bigger semi-span fin, that would draw your center of pressure a lot lower. As I make that bigger, it draws the CP pointer aft, and smaller fins, it pushes it forward. So that's ways when you're in the initial design, you can tweak the center of gravity, or sorry, the center of pressure. And then also body length, body tube length, like this 14-inch tube up here, if you were to make it a lot longer, that would draw your, well, actually it would do a lot of things. It would add more mass up front, and it would draw your center of pressure a little forward too. And then adding mass up there would draw your center of gravity forward as well. Or adding mass at the bottom could draw it back. So those are a few ways to tweak your stability margin. Okay, that's all I had for this RobSim session. Any questions on fins or stability or mass objects or anything we went over? All right, sounds good. Hopefully your epoxy is dry enough. We can do the outer plates now.
So who has done all their 8 sides of the fins? Anybody done yet? Okay, did you remove the tape also? Oops. I lost the crowd. Did you all remove the tape too before it's set up? Thank you. Okay, I can see. Thank you. Anybody else still working on the internal fins? We're all done? Excellent. William, how you doing? All done? Okay, if you have any excess epoxy on the outside of your motor tube or the inside of your motor tube, start peeling it off with the using your knife. Or if it's on the inside of the airframe, peel it off too on the edge. You know, if it's on this part here or this part here, kind of clean it off, or take your knife and shave it off. You have to. Just be careful, don't cut yourself. Okay, the next slide is going to be the outer fin fillet. This is most important. we've done the root or the tang of the fin, which is called through the wall construction. That's one part of it. The next part is the external fillets. And what we do is, here's where we use a lot of tape. Stuff like that. Like that. And we tape between the airframe and the fin at least a 1/4 inch gap between the fin and the airframe and the airframe and the fin. Okay? So you've got a gap kind of sort of like this. Okay? So what we want to do, we want to make a nice fillet like this. I have this fillet here dyed in food coloring. You can see how sweet that is. So when you use the tape to apply the epoxy, you can just pour the epoxy right on there, spread it with your stick at a 45-degree angle. Use the round part of your craft stick, and at a 45-degree angle, just screed it down to apply the epoxy. Now, before you start doing that, we need to make some dams. Number one tape that's on the leading edge, I want you to cut it with your knife, okay? So I got a nice clean cut like that right there. So what I want you to do, we got to make some epoxy dams, okay? Now we do have a gap. You might not see it, but there is a little hairline gap in between the root of the leading edge here on the airframe. I can see a little light through there. So what you need to do is, let me turn this. We call these little epoxy dams. You need to put some tape right there, kind of curve it in like this. Okay. The epoxy doesn't drip down through the root of the fin down the airframe, so it stays clean. Okay. You have to do the same thing on the back end. So what I usually do is cut the tape on the back end here, like that. And there's a little 1/2 inch gap too also. You notice there might be a little gap where the root of the fin goes. Make another little tape dam, I call them. Just like that. Make sure your rocket is nice and level, because when you put that epoxy, do both sides right here. Just do 2 sides at a time. Don't do all 4 right now. Just do 2 sides at a time. And the reason why I tell you to cut the tape on the leading edge and the aft end of that fin by the semi-span is because when you're done spreading the epoxy, you have to take this tape off right away. Because if you don't, it'll spider web on you in 2 minutes. So once you get the epoxy applied on, all I want you to do is keep the dams on. Keep the dams on, and then just take this tape off and pull it off. Notice the dams still stay on there because I cut the leading edge of that tape. And then take your airframe tape, do the same thing, pull that off. Okay? Keep the dams on for a little while. Do the same thing on this side. You can do 2 at a time. Do the same thing. Make a dam on this side, that side, and tape it off, just like you're caulking a bathtub or something like that. Same thing. Everybody capiche? Understand? Excellent. Thank you. Hold your rocket level when you're doing that too. After you get done doing 2 sides like this, I want you to rotate your rocket 180 degrees, okay? Do the other side, not the one that's 90 degrees, the other side. Because once you do 2 sides, you don't have to make a dam on one side because it's already got epoxy on it. but you do have to make a kind of a dam on the forward leading edge so it doesn't drip off the edge, the leading edge, or the back of the airframe, so it's not dripping into your motor mount tube either. So just be cautious wherever you think epoxy is going to run. Dam it up with some tape and make sure your rocket is level. And let it set up for a good 5 to 10 minutes before you rotate it, because otherwise it'll run. And like it says on that bullet, number 6 is that, rotate your rocket 180 degrees and repeat for side 2. Side 3 and 4 do not require any dams because you already have it filled in with epoxy. You're kind of beating the use of more tape, damming things up, but keep your eye on the epoxy when you spread it. A good idea is to take some epoxy. I'd go a little bit more than a 2-second squeeze on it because you want to put a lot of epoxy on there. What you want to do is mix some epoxy. Take your cup over the rocket and kind of scoop it out of there. It doesn't take much. I don't like we'll put like pour half of the length of the fin with epoxy, and then when you take your craft stick at a 45-degree angle like this, it'll spread pretty far. Guarantee it. So then you get a nice fin fillet like shown in this diagram right here. Cool here. See that one. So a nice fillet like that, no mess, no drips, nice and straight. And if you get a little bit over on the airframe, no big deal, just wipe it clean. You want to get a clean, smooth fillet the first time because like I said, once you finish it, you want to paint it, sanding epoxy is almost impossible. It melts more or less as it sands. So it gets messy. It doesn't actually melt, it gets warm, it gets gummy when you sand it. So, like I say, do one side, turn your rocket around 180 degrees or rotate it 180 degrees and do that side too, tape it off. And don't forget to remove the tape as soon as you get done applying the epoxy, even if it's wet. Just keep your rocket level, keep the dams in, and in like 5 minutes, you can remove the dams and rotate your rocket 180 degrees and do the same thing. And then do it to the two other sides that are left. Do we have any questions? Do we all understand? Are we cool? All right. Thank you, Sean. All right. Thank you, Daniel. UT2, you got it? Thank you. Abigail was shaking her head like, I got it. Yep. Justin, you cool? Okay. Jacob? Got it? Thank you. William? Just that I can't see your rockets or what you're doing, so I gotta have your attention. Excellent. Good job. Thank you. That's what I want to see. See, Nick's on the rocket range making a rocket. I can see that real good. Just watch where that epoxy is dripping before your time is up, and because I don't want you to get your rocket set up with some messy epoxy that you can't remove later on. or it's hard to remove. So this part here is called the through the wall construction, and I'll show you a different technique for your entertainment. There's another technique of applying your fins to your rocket. There's different ways of doing it. This way here is when everything is integrated into the rocket with your motor tube mounted in the rocket permanently. For bigger rockets, and probably you can do with smaller rockets too, the same thing. It's just that we do it this way so that you can understand how the integrity of constructing a rocket is kind of a 101 routine. Otherwise, on bigger rockets or even that same size rockets, you can cut the fin slats all the way to the end of the aft, okay? Just like so. And of course, you have a template that aligns your fins up and your motor mount is all put together, and I actually fiberglass the fins to the motor tube, just like that, aft all together, motor tube all together, and totally constructed. And sometimes it becomes a chore at some point, but 2 people are guaranteed to do it. A couple of different tools. So I got a little trick to the trade here. I use some shims to put in there. Just like that. And we'll right in. Right on to the bottom, and all you gotta do is do a external fin fillets on this rocket. But that's your option. And believe me, compared to what you see in the book now on how to construct a rocket, you don't even get a 30 seconds of information on constructing a rocket when you buy a kit. It's like a 1-pager, and it's a lot of text in one picture. That's all you get usually. And it's been like that for decades. They have never improved the technique of building a rocket on instructions when you buy a kit. The only way, if you have trouble constructing a kit, a lot of people have YouTube videos out there of a particular model to build. And you can look at that, and it's very informative. Everybody has a different technique. This is just rocket building 101 right now. Cheers.
How's everyone's fillets coming along?
Can I see a couple of them close up at all? Without picking it up and dripping? All right, very good. Very good, Andrew. Nice. Perfect. Oh, he shut his camera off. Okay, thank you, Daniel. Perfect. Scott, yep. Very good, everyone. You guys are too easy. UTT, you're okay? All right, thank you. Montana, looks like you guys are doing real good. Excellent. Sean, how you doing? My Vanna White. All right. Oh, Abigail's talking, but not to me. Make sure you got epoxy cleaned off, that you don't need to have it. You'll have to get in your way. Picture of it better.
Hey Frank, do you mind if I show that fin failure video in the slides?
Sure, yeah, go ahead. Great. Excellent.
Yeah, while you guys are working, we linked a video of what happens if fins fail. And it's like literally the fins coming off of the rocket, but it's just an interesting video. Yeah, so if the fins come off, messes up your stability. That's an example of what would happen.
Looked like a signature in the air.
I know, yeah. Lots of loop-de-loops.
Yeah, do not fly this rocket. Just fly it on the recommended motor, because the fins aren't that strong to take close to Mach. They'll rip right off. Usually, if you're going to be going Mach, you really have to do a good fiberglass layup. You got to be G10 fins, aerodynamically, airfoiled, and preferably 3 of them and kind of short. Not so much mass, not so much coefficient drag. But the motors we're using, you're way below Mach, maybe 300 miles an hour. During the competition, same thing. You're not going to gain any more than 400 miles an hour on your rocket, if that, at that short distance. Justin, you all done? All right. Thumbs up if anybody done. I want to hear a thumbs up if you're done with the external fins. All right. Thank you, William. Justin. Somebody at UT. Okay. Thank you. Is that Haskell? Yeah. Thank you. You guys got a bunch of Haskell has a bunch of high power rockets in the closet somewhere, don't you? Just remember to wipe off the excess epoxy that's dripping that you saw when you ripped off your tape, or when you look the other way and go, whoop, I missed the spot. It's on the next slide, Rob, so I can gauge myself here.
I don't know if you'll believe me, but it actually is the afternoon break. But after that, it was aft centering ring.
That one's out of order. Oh, really? Aft centering ring? Oh, we have to do the rail buttons, don't we? Okay. I thought there was a slide for the rail button. There it is. Okay. Yeah, we got to do the aft first before the rail button. That's right. Okay. Go back to the aft then. And that's good enough. Yeah. Cool. Don't anybody work ahead. Please don't work ahead. So everybody's done with their external fin fillets. And I meant to tell you, the people taking, this is probably kind of late. That's what the paper plate is for, is to put your tape on that paper plate. Unless you have a handy garbage bag, but when you put your tape on the plate, it kind of piles up right there in one spot, that sticky stuff. And once you make a masking tape Christmas tree on the paper plate, you just throw the whole thing off. Okay. If the people that are done doing their external fillets, like I said before, why don't we sand the internal part of the aft and the external part of the aft on the outside, and because we want it to slide on real good between the motor mount tube and the internal airframe. We don't want any hang-ups. So what you can do too is take your number 8 wood screws and put them in halfway or so. They act as little handles, so you can pre-fit and pull it back out before we apply the epoxy. Make sure it fits in there real good. Sometimes you have to use a little ingenuity by putting them in if it's too tight. And of course, when you put your aft ring in, make sure it is not lined up. Make sure these wood screws right here are not lined up with the rail button, okay? Because we're going to drill the rail button into the side of this centering ring, okay? So we don't want to hit that wood screw. So just kind of make it off center from the fins and the wood and the reference mark for the rail button. Make sure to put those screws into the aft centering ring, so you use it as a handle to pull it back up. You might get stuck. And make sure to offset it from the rail button alignment and the fins. And just kind of push it on best you can, without mushrooming the motor tube or the airframe. And it should go in a good 1/4 inch setting in there. Once you establish that, pull it out. If it's hard to get out or hard to put in, and it does work, either way, as long as it gets in, as long as you can pull it out. If it's tough to push in, but you can get it in. Once you apply the epoxy that we have to put on there, the epoxy almost acts as a lubricant, and it'll slide right in. You got your uniform on, Connie? Okay, once you pre-fit your aft closure, your aft centering ring, make sure it fits good. 'Cause once you get it in, you don't want to pull it back out and sand, because that epoxy will set up on you. If you have to sand the tube, go ahead. If you have to sand the airframe inside, go ahead. Sand it up. Apply some epoxy if you want to, which is a good idea. Why don't you let's put some tape on the inside of your motor tube in case epoxy gets inside. Make sure the tape is in there even with the aft end of the motor tube. Okay, and you can put this on pretty slick without scooping any epoxy in there when you're applying it with your craft stick. Apply your epoxy on the outside of your motor tube and on the inside of your airframe, okay? Because this aft ring is going to touch each 4 of these tanks. That's when it bottoms out. So pre-fit it first, put it in. Should stop right at the tank. Pull it back out. Apply your epoxy and push it back in. Don't forget to put your gloves on again if you haven't taken them off already. By now, you should be able to know how much epoxy you can use now. Gauge yourself on how much epoxy. I know you guys catch on. You're doing pretty good. You guys are doing real good. Make sure you put it on the outside of the motor tube and the inside of the airframe. If you want, you can put tape on the inside of the motor tube in case you get a little epoxy in there, and then take the tape off as soon as you install your aft motor mount ring. You don't have to have the aft on the outside. You can have it on the inside, doesn't matter. But remember, make sure the screws are on the outside. And make sure that your screws are not lined up with your rail button reference line or your fins. Make them off from the fins too, because once you screw it in, you'll be screwing them into the fin tab. But we don't want that. You just want to screw into the motor mount ring itself, nothing else. Once you have your epoxy in and your aft ring in, take your tape off. We'll let that set up. I'd keep the tape. I would keep the. I'm not gonna say that. We're good. Don't really need to put a fillet around the motor mount too, because we after this all sets up, this goes on, and it has to fit flush. So we don't want any epoxy on the edge of this motor mount tube. It already has epoxy on the back side of it. No big deal. You don't need epoxy on this side, but you do need epoxy on the outside to make a fillet right here. You can do that if you wish. Try not to get it in the hole. What I've done in the past was just take tape and your craft stick and push it on, just like that. Make a little tab here that you can pull off the tape, and just make a nice small fillet around the aft motor mount ring to the airframe like this. cover the other hole up too, if you wanted to. Just like that. And once you made the fillet, you can pull these tape plugs off like that. You should be good. If a little epoxy gets in the hole, no big deal. Just take your awl and just push your awl through it to make the hole. Another thing too, just to let you know, epoxy does not adhere to metal, so it won't adhere to the screws. It'll be on there tight, but it will not bond to it. It'll just adhere to it. It will not bond to metal. This will be your level 1 motor, the kind you'll be using, and we're going to go over this to prepare it. When you go for your certification level 1, you are expected to, once you're handed this motor, there'll be a mentor or me watching you prepare the motor. We'll be doing this in slides in a little bit on this, and I think we'll go by the slides, but we'll go live too, and I'll show you how to prepare this motor. Like I say, there's hardly any tolerances in this motor tube, so if there's any debris, epoxy in there, it will not go in. Make sure when you go to your launch field or here, make sure you have these parts, these little screws. Install them inside your rocket or where they're supposed to be at. Make sure they're in there secure. That'll hold the motor in. Because when the rocket gets apogee, it ejects, and we want this motor to stay in there when it ejects. We want the parachute to eject, not the motor. There we go. Cool. And when you tighten down the motor with the retainer, just tighten it down snug, don't strip it. And you're probably going to ask me, well, Frank, what if this wood screw strips? Well, you can make another hole. Just shift it over a little bit, and you can make another hole, and you can pre-drill a hole in there, you know, smaller than the number 8 wood screw is, and you can just apply another, make a couple more holes and to hold your retain your motor in place. Okay, I need to see some pictures. Hello, people. All right. Okay, everybody show me your aft motor mount that you have installed. You have the center ring, do you have it in? Think people are having problems, they're still sanding, huh?
Haskell is still putting their app in.
Okay,
Us too.
Montana Tech is still working on their app.
okay.
Do the
Wait, I got a question.
anything specifically?
Pardon me? Repeat it, please.
We got it, thank you.
Okay.
So I got a question. Is it this tube right here?
Now we're not working on that. We're working on the app part here, okay? You got that
Okay.
in? All right? This part here, is this what you're talking about? Water retention?
Yeah. Okay.
Yep, that goes in when once you have your aft, is your aft in epoxy in there?
Oh no, not yet.
Yes. Yeah, put some epoxy on the outside of the motor mount tube and the inside of the airframe.
Okay.
And make sure that your aft fits in there real good. Did you pre-fit your aft in there?
Yes.
Okay, perfect. Apply some
And
epoxy
what type
to
of screw did you use?
It's a number 8 wood screw. You should have actually you should have a total of 4 of them.
Okay.
2 are for the retention for the motor cap, and the other 2 are for the rail button.
Okay.
And I would suggest on putting some tape on the inside of your motor tube when you apply the epoxy, just so you don't get no epoxy on the edge of the tube when you put it on. Thank you. Sometimes it becomes a difficult part. Like I say before, if it's real tight to get it in, and you know you can get it on, you can take your thumbs and make sure your wood screws are not lined up with your rail button reference mark. Make sure your wood screws are not lined up with your rail button, okay? Or your fins. Make sure it's kind of like off a little bit. And you can push them in with your thumbs. It'll snap in. You push down with your thumbs. Once you have the epoxy in there, it'll go.
It's like not doing it, just not want to fit.
Not going in?
Yeah, it's not going in. We're trying.
Sand, sand, sand.
Yeah, you need to sand it black against it. And then
Yeah, sand the black stuff off of it and try not to mushroom the airframe or the outside of that motor tube. If you do, kind of sand it. And like I say, you can take your sandpaper that I don't have in front of me. There we go. Well, you take your sandpaper and you know, use your craft stick as your finger to sand it. This is a small piece of sandpaper, but you can do one side, rotate it, do the other side, real good. Even try beveling the side you're putting in. I'd have a longer piece of sandpaper here. The side that's going to be in contact with the motor tube, you can kind of bevel the inside of it like this, so it has a smooth entrance to the motor tube also, and you can do the same thing on the outside of the motor mount ring. You can bevel the edges if it's hard to get in, plus the sides. I'm thinking when you start doing to get a bevel on the edge of it, it'll probably fly right in. You just do a bevel on the side, just like making it round. And if it's super snug, but it fits, it'll go. Like I said, when you apply the epoxy, it'll slide in like a lubricant almost. But Mr. Noble, you said it would work. Well, try your best. Because we did pre-fit the aft before, of course, for the motor tube. So it's probably kind of snug. You can make it looser, but I'm sure the outside of that motor mount ring is probably a little tight for the airframe. So that's what a little sanding of both the tube and the beveled edge of that motor mount ring should work good for installation. And Sean, how you doing? All right. You're a star.
Dancing monkeys.
What's that, Scott?
Oh, our lab lights keep shutting off automatically. It's driving us crazy.
Motion sense?
Yeah, but they can't disable them because they lost the instructions.
Isn't it like you turn them on, turn them off, and turn them on?
Well,
Sequence?
we got to keep moving. So if you see us dancing and flapping our arms, that's partly out of excitement, but
I get it. William, how you doing?
Yeah, I'm getting to screw in the AFT, but I should
Okay.
put the resin in.
Oh, you got it to fit
Do
and
we
everything?
need to put this right here?
What is that? You got kind of like, oh no, that's a nut. Is that a nut?
Yeah.
No, you don't need that. Just the
Okay.
wood screws. Oh. Yeah, you got to put the wood screws into the aft to use it as a handle when you either put it in or take it out when you're pre-fitting it. And make sure the wood screws do not line up with the rail buttons or the fin. Jacob, how you doing?
Well, I'm just trying to get the aftering in right now.
Does it fit good? Oh, you got it in there with a pocket? You got it in there with epoxy?
No, I still need to put it in. I'm trying to sand it and everything.
Okay. Yeah, use your craft stick wrapped around with some sandpaper and bevel the edges of it that you're going to be putting it in. It helps a lot. Bevel the corners. That's why I said earlier, I go, if you're watching a demonstration on RockSim, you could probably look at the same time and sand your aft, the in and the out, but you're good. We'll get it done. Aaron, how's the weather by you? Sunny, clear, and warm?
Sunny and clear, warmish,
Okay, well, what's warmish, like maybe 70?
like the high 60s, low 70s.
Okay. Yeah, we got a whole 10 degrees here.
Don, how's the weather by you?
It's not too bad. It's everyone says things in Celsius, so it's about 18 Celsius. Yeah. But yeah, it's been nice weather. Hasn't rained a lot or anything. I don't think it's rained a day since I've been here. So happy
Yes,
about that.
Daniel.
Yeah, go ahead, Dan.
So the the retention cap, what are we doing with this?
You're gonna be putting on the rocket later on, not right
Okay.
now.
Because we have to put the motor inside, right, and just hold it on.
Yep.
All right, thank you. I didn't want to apply that right now and then just be stuck forever.
Right? If you want to stand up your rocket before you fly it for you want to present it or something like that, keep the motor retention cap off because it'll be kind of tippy with that on. I would put it maybe in the booster or tape it inside the booster, put it inside the booster so it'll be somewhere in there when you put the sustainer back on. It'll be in there. But your screws, keep your screws in there, screw them into the aft as far as it'll go so it clears so you can stand the rocket up if you want to. And then report to me how many times the rocket fell. You bumped into it and stuff. Kiana, how you doing? Where's that mute button? I'm behind. Okay, cool. I don't want you getting too far behind. If you need instructions, we do have a breakout room if you need it. Let us know.
And of course, during the open build, when we're working on parts like this, feel free to take off mute and like ask questions. You don't have to like raise your hands. It's a good time to interject to make sure like if you're having any questions.
Get it all together there, William?
Yeah, I'm just waiting for the resin to dry on.
Okay. Jacob, looks like you're moving pretty good.
Asking.
Haskell wants to know if they can go ahead and tape off their other wings.
Or do we wait?
Tape what?
They're supposed to be.
Oh, the fins.
They're supposed to be done.
Yeah, you can take the tape off the fins, sure.
No, go ahead
Doesn't
and start taping them.
Oh.
Taping them to add the fillets for the other side.
Oh, you have to do the. Oh, yeah, go ahead. Yeah. Have you done any of the splits yet?
Do what?
Have you done any of the external fillets yet?
Yes, they've got some fillets done, but they wanted to know if they can go ahead and start adding tape to do the other fillets.
Yes, you can. How many do they have done? Have done just one set or two?
Two.
The one
Yeah,
set.
Yeah, the one set that we, yeah,
So you have, yeah,
We have like,
you have this many or these two done?
we just have
Just
what
one
you said, dude. Just one
yeah,
set.
just the one set that you had, the ones we
All right,
did with you
all right.
together.
Okay, then rocket and flip it over 180 degrees and do these two.
Okay, thank you.
Yeah, we were supposed to.
Other ones, you don't have to, put any dams on them because there'll be epoxy blocking it anyway.
Yeah, I think.
Ultimately, do we do all 8 fillets?
Yes,
Okay. We're 4 fillets in it ourselves.
okay. Anybody got any bad rocket jokes? No?
Do you?
Yeah, do you?
No, they're all dumb. I mean, they're dumb, but they're really stupid.
They're out of this world, you could say.
What do you call a rocket's favorite tune?
Favorite
wait.
what?
Favorite song? A space tune. I don't know.
Nice. You looked that up on the internet, didn't you? Jason. People that are putting their fin fillets on, external ones, don't forget to take the tape off right away as soon as you're done spreading the epoxy. Take the tapes off right away, except for the dams that you've made so the epoxy doesn't run all over the place. Hey Nick, how you doing? You're pretty quiet. Are you down with your Phillips, Nick? Okay.
Yeah,
Go ahead.
yeah, I got everything in already. I'm just waiting.
Okay, you got your app in?
Yep.
Okay, cool. All right, nice. Thank you.
Did you want to know if we had motors?
No, I did.
Oh. We have motors here. From like 2018.
You really?
Yes. Yeah,
Who had those there, I wonder?
you guys.
Oh, is that
I
when
think
you
there's a launch to
Oh,
learn with a bunch of people and then a lot of them dropped out, so.
from last year?
From like 2018, I think. Like
No,
5
from-
years.
We traveled there, Frank.
Yeah, but we were gonna, I wouldn't have delivered the motors though.
I don't know what you guys. When you guys would go there and do the launch to learns at the school, did you bring motors?
Nope.
Hmm.
So they must have been shipped there for a reason, because the 2018 was gonna certify, and they never did find a launch site, possibly.
That is an extremely quick timer, Montana. Like, I feel it hasn't even been 5 minutes and it went off for you twice.
Oh, you're noticing that? Yeah. Usually there's 30 people in this lab, so just the two of us apparently don't create enough chaos.
Yeah, the sensor's like right above me, right over here. But I have to hit it right in a specific spot in order for it to see me.
It's good for us.
Goodness.
Extra steps or something during the day.
Yeah.
I have a bit of a problem right now. So I was trying to put my aftering in and it's stuck and I can't get it out.
I can't see who's talking. Oh, that's Jacob?
Yeah. I don't know. I'm trying to get it out. I was trying to like see if I could pull and turn it with the screws, but that was just breaking the aftering. And I think I just really messed up.
Can you show us?
Yeah. You can like see through there. I was trying to get it out, and when the screw came out, and it's kind of damaged here a bit and on the sides. Me trying to figure out ways of getting it out, and I'm just having a bad time right now.
You don't have any
Okay.
epoxy, do you?
No, there's nothing on there. It's just me trying to dry fit it. It's stuck.
Okay. Looks like you got one end almost out.
Yeah.
So why don't, so the hole that you have open right there, it's more or less kind of stripped. You can't really use a screw in there.
Yeah.
Okay, why don't you take your awl? Well, you're gonna end up pushing the unit again. You don't have a drill there by you, do you? You have a drill?
Not by me, but I should be able to find one in my house.
Yeah. You could drill a hole next to that one there, or use your awl and just kind of make a hole and take your wood screw and try to drive it in, make a fresh hole right now, and put it in halfway and see if you can pull it out. You're gonna end up pushing it in some more when you use your awl. I don't know if you can, let me see if I can, if these things are sharp enough to get into the wood without pushing down much. No, you're gonna have to make a hole because it will not go into this plywood at all. You're gonna have to make a hole of some sort that the threads can grip the wood.
Pushing with the awl is good, just push it down farther on there.
What about the awl? Can't you stick the awl in that hole and pry up?
Yeah, I'll use it as a wedge, as an angle.
You know, you don't have to have it towards the mortar. You can have it on the side, left, right of it, and try and pry up.
If you grab both of them at that same rate, you got to pry it.
Grab them at the same time. You'll grab the screw and that awl and pry at the same time.
There you
to
go.
the side, left. Put that, you got that airframe between your legs and squeeze to hold it. Yep. There you go.
Made a noise.
Keep going.
Almost.
Use the awl the other way. Use the awl the other way. Go the other way with it. Yep. There you go.
Oh, that screw came out.
Keep prying it open. You had it loose. Okay, now go underneath it with the awl so you can pry it out. You stab yourself.
Yeah.
Be careful.
Try putting the hole, put the awl in the other hole.
Yeah. Once you get it up, see if you can pry it off between the airframe and the. And you can take your screwdriver. You got that screwdriver too. Might fit in there too.
Breaking it.
I swear you had that thing like almost out.
Yeah.
Wow.
Yeah.
Can you get between the ring and the airframe at all?
I've tried like right here, and like kind of broke it a bit.
Well, push it in all the way. No, not that, not that. You're off. Push it all the way in. And use a little side motion on that, a little side, like towards you, point it towards you. Yep. Okay, now go where there's a fin tab is at. Go by where the fin, where you have that other hole made. That you had a hole made right there in the airframe. Yep. Yep. Use the fin tab to pry up, not the airframe. Use the fin tab. You have to. You have to use your. You can get the all. Can you see my camera here?
No. Yeah, I can see it now.
Yeah.
No, okay.
Put it in like this. You're all, and see I'm up against the pin tab right here.
Yeah.
Yeah. Pry up like that against the pin tab. Like this, up, not down, up.
Frank, do you think that Bob should go into a breakout with him?
Sure.
I don't want to slow you guys down.
All right, we'll work with you.
It's just. Because I'm looking at the frame and it's breaking, and I feel like it's just like getting messed up.
Yeah, the airframe won't be so bad. That can be covered up with epoxy or whatever and sanded, no big deal. But just don't rip it, several inches, that's for sure. If you got little divots in it, no big deal. That can be, that's makeup. Oh, Bob will help you in a breakout room.
Got it out just now.
You got it out?
Yeah.
All right, let me see the damages.
Yeah, it looks pretty bad for me.
Oh, let's see it.
If you can
Rob,
see that.
Okay, oops. Oh, that's not. Okay, you need to do a lot of sanding, okay?
Okay.
Sand that airframe real smooth. Let me see the edge of it. Let me see the side of it.
Edges are even worse, in my opinion.
Oh, that's not bad. You'll see that on the first landing of the rocket.
It looks like I shot it before I even made it.
Just sand the inside of it and sand your aft closure some more. Okay. Let's see what the rest of the group is doing here. Does everybody have their aft centering ring in? I want to see thumbs. Okay, thank you. Abigail, Justin, Aaron, Daniel. Thank you, Nick. William, good job. Montana, you were cool? All right. Everybody's got it? Okay, thank you, Jana. What about Haskell? You're still doing your external fins, correct? Okay. Are we taking a break?
Hey, Frank, what happened to Jacob? I thought he was coming in at the.
No,
Yeah.
no, he got it. He got it out.
Oh, okay.
The second we started moving you over to the breakout room,
Yeah.
finally popped off.
All right.
Make sure your wood screws are not lined up with your rail buttons or your fins, especially your rail buttons. No big deal on your fins, but just to keep them clear. Are we going for that afternoon break?
Yeah, if you think we're good for it right now.
Yeah, why don't we take 15? Is that okay?
Yep. So about 3:05.
Yep.
All right.
Is everybody with Jacob caught up or what?
Yeah, we got
We want to drill so that it has a seat. We'll just drill a little ways because it only sticks out.
it's up to you people. It depends how accurate your craft stick is on your 18-inch dowel. You can take your knife and carefully cut the craft stick off, cut the tape and remove it so you have an accurate gauge to use. Because when you stick it in with the craft stick, it might be bending on you. Or you can use the upper end, or use the other end of the 18-inch stick. And I want you to insert it in the forward part of the booster. And make sure you're not touching the recovery harness or the eye bolt. Make sure it's touching the forward centering ring, okay? Make sure you hear that little tap. And what I want you to do next is mark it on the mark your dowel right at the forward part of the airframe. Do the same thing, transpose that measurement. Here's your mark. Line up your dowel on your reference line where your button is aligned. Go to the end of your dowel. Make a little crosshair at the end of your dowel. Take your craft stick, which is 1/8 of an inch thick because your forward motor mount ring is 1/4 inch thick. So you want to add that 1/8 of an inch towards the aft end and make that crosshair right there, and that's where you're gonna take your awl and twist turn carefully right on the crosshair. And I can tell I am right on that forward centering ring, motor mount centering ring, because I'm not punching through the cardboard. I'm in the wood, or pretty darn close to it. You don't have to go all the way in. Just make a hole, just pre-drill a hole with your awl.
So measure down to hit that one.
Pardon me?
Work on that.
Okay, is everybody have that established by now? Thank you, Daniel.
I just finished doing that apogee. I wasn't really paying attention during the whole thing because I was trying to get it done real quick.
Okay, Jacob, you got the aft ring in?
Yeah.
Great. Excellent. Okay, let's do that one more time. Here we go, Jake. Or you want, no. This will be quick. People didn't get it. Okay, Jake, and the rest that need to finish up on the rail button installation, take your craft stick. Okay. You're gonna install a rear rail button. Take your craft stick and push it in like this, and let it touch the aft of your motor mount ring, and then mark it by the airframe, how deep it's in. You should have a mark like that, Jacob. Sorta. Got it?
Yeah.
Okay. Transpose that measurement to the outside. Take your pencil line to the edge of the airframe and mark it on your reference line where your rail button reference line is. You should have like a crosshair there, okay? Got it?
I think so. I got that. I think I got it, yeah. Something like
Okay, now you have to add,
where I put,
Yeah, show it
I
up
mark it on the airframe. Do I mark it
yes,
on the
mark it
airframe?
on the.
Okay, yeah,
Yep,
then I
right
got
on
it.
the- Got it?
Yeah,
Okay, now, since the motor mount ring is a 1/4 inch thick, you have to add 1/8 of an inch to that mark forward of it. So your crest tip, the thickness of it
yeah,
is actually 1/8 of an inch thick. So take that mark that you made and gauge your thickness of your crest stick, make another crosshair 1/8 of an inch forward of that first crosshair you made. And that will be where you'll take your awl and push it in gently. And just make a small hole. And it should be sinking into your aft centering ring. You got it, Jake?
yeah. Just put it in the hole.
Now you may have to hold it with 2 hands. Just hold it with 1 hand and then just push the awl in a little bit. You only just got to do a pre-drill of the hole. Because if you pre-drill the hole, the wood screw will drive itself in. I think Sean described that better at the rocket build.
So the hole has to go into the aft ring, right? Or,
Yeah. Yep.
okay. Wanted to make sure.
That's the object, to sink a wood screw or that rail button into some kind of meat, which is the aft ring. But we're not putting the rail button on yet. We're just making the hole. You got it, Jake?
Yeah.
Okay, once you got that hole done, turn your airframe around, and we need to work at the forward part of it.
Mhm.
Top of the booster, like this, end.
Yep.
Take your 18-inch wood dowel that you have.
Got it.
Put it inside and touch the forward motor mount centering ring. Make sure you're not touching the recovery harness or the eye bolt. Make sure you're touching the wood ring, okay?
Okay.
Okay, keep that thought right there. Keep that dowel in there and mark your dowel on the end of that airframe forward part. That's your reference line. That's how deep that gauge is going to be. Same thing we did on the other end, only it's a little further in. Got it?
Yeah.
Okay, take your dowel out, transpose the measurement to the outside, line up your mark you made to the end of the airframe, forward part. Take your hand and hold the dowel down like that. Make sure it's lined up along the rail button reference mark. And make your first crosshair across that reference mark on the end of the dowel. Okay? Got it, sir?
Yeah.
Okay, now what do we got to do? You got to do the same thing.
Okay.
We have to add 1/8 of an inch, which is the thickness of the craft stick. Add 1/8 of an inch towards the aft of that first crosshair you made. Make another crosshair. And that's where your second rail button would go. You take your awl and make a pre-hole in there, please. Okay, everybody, I need some epoxy, small amount of epoxy mix. Then what we're gonna do, we're gonna drop a little small amount in the hole. And of course, the molecules on epoxy kind of works the same way as water. As it gets to near the surface of a glass, it doesn't want to overspill right away. The molecules in the epoxy is very, very large. So you have to actually push that epoxy in, probably with your awl. It'll go in there better if you push it in with your awl. Just a drop, just a small drop of epoxy, push it in there with your awl, and then take your number 8 wood screw. You should have 2 left. Number 8 wood screw. It's got a Phillips head on it and a pointy end, very sharp. Don't use the machine screw. The machine screw has a nut. These are extra parts. If you're required to use them for your rail buttons, but we're going to be using these number 8 wood screws. And take your Phillips screwdriver after you applied your epoxy and set the epoxy in. Screwdriver crank. And make sure when you screw your rail button in that it is straight and level. And as you're driving it in, do not crush them in. Just lightly snug it to the airframe, because you can actually squeeze the rail button where you almost squash it and it will not fit on the rail. It'll be too tight. So apply your epoxy in the hole. Make sure it is level.
Don't forget to slip your rail button on.
Well, I hope so. I hope they're looking at the camera.
Yeah, put the screw through the rail button first.
Yeah. See the picture? Should just look just like that. Be perfectly aligned with the next one. There's the aft one. Should be about a 1/2 inch from the airframe. Just a cautionary word. If you're going to be doing the competition and you need to put the rail button farther up, and you can't get it into the motor mount ring, you'll have to use these machine screws. Put it in. That means you have to get your hand in there. It's a 4-inch. During the competition, the gateway competition, of a 4-inch tube, you should be able to get your hand in there to hold this nut and tighten it down. You got to reassure that this nut and the threads do not get hung up on the recovery system too. Because that'll be where the recovery system is. It doesn't get hung up on it. Everybody got that? All right, thank you, William. Good job.
Wait, Frank,
Thanks.
I got a question.
Yes.
So the nail is coming out of the wood. If you look closely.
Wow, yeah, you're awful. Did you add the 1/8 of an inch?
Yeah. I think it got angled and then.
Yeah, probably that's why it's probably angled, and it's kind of
Okay.
cocked and it's not straight up. go down with it a little bit, go down,
Okay.
yeah. You may have to pull it back out and straighten it out if you want. And you could probably make a straighter hole with your awl, maybe your awl wasn't straight either. And the screw just followed the hole. So they should have mentioned that, make sure your so you're gonna make sure when you do your awl, it's straight. We don't want it cocked this way, that way. We want it straight in. You know, we don't want it left or right or forward or back. We want it as straight as possible. There is a little leeway in these a little bit, but if they're off like a lot, like what Williams was, you want to pull that back out and take your awl and make a straight shot and then reapply the epoxy, or you probably got enough epoxy in a hole where you could reinstall the rail button in a straight manner. All right, thank you, Daniel. John, doing good. Justin, how you doing? Thank you, Abigail. Perfect. Jacob, how you doing?
Oh, I didn't realize I was still unmuted. Doing fine. You said something about epoxy on the screws or on the.
Yeah, when you have your hole made with your awl in your rail button, I want you to put a drop of epoxy in that hole.
Okay.
Take your awl, kind of push the epoxy in there.
Okay.
Because it's not going to bend, okay?
Okay.
And make sure your rail button is straight, level when you put them in. Diana, how you doing?
I have a question. So do the rail buttons need to be flush with the body of it, or is it okay if it's?
Yeah, rail button should just be snug with the airframe, yes.
Okay.
Yeah, we don't want the rail button to spin.
Okay, I don't know if you can see that, but there's a little bit of space right in between the rail button and the
Oh, you could see that push down and screw it in tighter.
Okay.
Yeah.
Okay, thank you.
Yep. You must have hit that wood right on. Yeah, that wood screw should drive in. Once you have a pre-drilled hole to a certain extent, it should grab onto that wood and just push down and turn until the rail button touches the airframe. How you doing, Nick? All right.
William, did you get theirs straightened out? Okay.
Thanks, William. Good job. Oh, Haskell, how you doing? You want to talk to me? I need some more positive rail button installations. Thank you. Got it. Thank you, Haskell. UTTC, you were good? Good. Thank you. And yes, we were at your college in 2018, and we did not deliver any motors. We must have shipped them to you. Something happened. Montana, you good? Okay. All right, we're pretty cool. Next slide.
Actually hands back over to Aaron.
All right, wonderful. This one will be just like what you guys just did. We'll be putting rail buttons in the Roxen rocket. So how we do that is the main effect on the simulation that the rail buttons do is aerodynamic. So we add it as a fin, but we only do a quantity of one. That's what this screenshot says here. So I'll go and switch to mine and we'll walk through. If you are able to follow along, I would suggest doing so. If not, no, maybe. All right, so we're back in Roxen. So look at your main airframe tube here. We'll go ahead and add a fin. So go add new components, fins, and go ahead and cancel that. The database, we'll do the aft one first. So aft rail button. There's one of them, and it's about I think a 1/2 inch square. So root and tip cord are 1/2 inch. And then semi-span should be a 1/2 inch. And then sweep, let's see, sweep angle, it should either be 0. Let's see which one. So yeah, do sweep angle of 0. And then for the position, put it over your aft rail button, or sorry, your aft centering ring. So like that. Choose a plastic, I think black plastic. You can do like is polystyrene accurate, Frank, you think, for material?
Yep.
Matters that much.
Yep.
So we'll do that. Oh, thickness also a 1/2 inch. Cross section square. Finish. No, you can leave that. And then the important part, just for accuracy, right now it's coincident with one of your fins, but you put it 45 degrees. So just go to your radar position and change that to 45 degrees. Just type it in. And you're done with the aft rail button. And then, so click OK. And you can either repeat that process. I think there is a copy paste function. I've had trouble with that in the past. No, but I'm gonna try it again. That work.
I know I can never get that right either.
Oh, okay. So you do the copy on the actual component and then you select the parent component and do paste and it should paste it in. Is that working for folks? So just choose one of those and rename it forward and then change the position. Make sure it's the side. And you should be able to check on the 3D view. This doesn't crash my computer. See if that looks accurate or not. Yeah, so that's the way we approximate it.
What material did you use?
I chose polystyrene PS, I believe. Check again. Oh, it did not stick. Oh, sorry, that's the actual thing. Sorry. About that. Roxanne just unexpectedly quit on me. Jeez. Save anything I was working on. I do have a previous copy though from last workshop. Let me just open that. Polystyrene, yes, is what I chose. So this one looks like. Just keep it consistent, whatever square dimension you choose to resolve for these boxes. So and was that? What else? Am I going over parachutes yet, Rob? Do you know?
Parachutes comes right after this rock sim. So yeah, if you'd like to enter it a little bit.
Okay, yeah. So yeah, let me bring up that slide real quick.
Should be 89.
So rail buttons.
Yep, just after that.
Okay. This slide was the mask. We went through that. You could add masks for your epoxy or mass objects for your avionics, your L timbers and stuff. So we covered that earlier. And then okay, here. So parachute selection. I kind of mentioned this before, but the descent velocity from the simulation, you want to aim to have it at least not faster than 20 feet per second, or in Tripoli's case, 30 feet per second. So like if you have a 24-inch chute and you're landing at like 35 feet per second, you want to go for a little bigger chute than that. But if you go for like I don't know, a 6-foot chute for this size of rocket, you're coming down at like 5 or 10 feet per second. That's a little overkill. You do not need to land that slowly, and that'll just make it drift farther. But I just mentioned down here the accuracy of the simulation of the weight makes this parachute selection be more accurate. So that's just why you try to want to make sure your masses match for each of your parts. So if you have access to a scale at some point for your competition rocket, that'd be useful to like weigh your fins before you put them on, and then make sure the mass and Roxanne matches. So the parachute options on here. The important thing here is the outer diameter and shroud lines, I believe. So right now in the database, we have the lock 36-inch chute selected, but you can, depending on where you're buying your parachutes from, you can choose another one. So like Lock Precision, they have a put the 86-inch chute if you want, just, and it shows it estimates its packing volume there. And so you probably wouldn't be able to fit that. Well, you might, but probably not. But if you were to run the simulation on this chute, though, it should change your time. Let's reload the H100 back. 6-foot rail. And then launch, or you could do this flight profile thing. It's that animation. Sometimes it's a little annoying. It takes too much processing power, but it can be useful sometimes. So just scroll forward. So there's a lot of drift on this one, as opposed to using like a 36-inch chute. Try that again. 36-inch chute just to see.
Yes.
See, it comes down a lot closer to the pad, but it's still at a safe speed. Now, I'll have to follow up on how to get the landing speed to show up. You might be able to plot it. You can do custom graphs. You could show its velocity over its entire flight. It's like velocity is the red graph here. So down here, you could zoom in. So that's like 20, what's like halfway between the 50 mark, 25 feet per second about, or 20, 22. So that's under the 30 recommended by Tripoli. So the 36-inch chute is good. Any questions on parachutes in RockSim or descent velocity or anything like that? And that's Frank.
You're muted.
You got me.
Can you hear me okay?
Yes.
Okay, we have certain components of the recovery system. This is kind of a little X-ray part that has the motor tubes hanging out of the airframe. As you can see, we have our little slip knot, and we have a recovery harness connected to the chute protector, which is a Nomex orange piece of cloth, which is connected to a quick link. That's what we call these little quick links. You should have two of these quick links. Two of these things. These are called quick links, and they should be rated, stamped on it. It says 660 pounds, which is plenty for your rocket that you're going to be using. And of course, it's quick link to the recovery harness with a slip tie knot, and it is connected to the Nomex chute protector. And the other end is connected, of course, with a quick link to the sustainer section. So it's all one contained module. Next slide, please. I'm just showing you this. We're not doing anything yet. Okay, what I want you to do is take your 18-inch dowel and push it on the aft end of your motor tube. Push your recovery strap out of your tube. And you're probably saying, well, I don't see it or I can't reach it. Well, what you got to do sometimes, you got to kind of bang it, shake it out like that, and it should come right out. There you go. Perfect. And if you can't shake it out, stick your hand in there. You should have, might be able to grab it or grab it with the other end of the dowel and grab a loop with your dowel on the other side of it, on the forward part of it. Everybody have their recovery outside the booster section? Oh, Daniel's got thumbs down. Jacob's got his out. Unwrap it, take the tape off. And Jacob has his hand stuck in the rocket. All right, William, you got it. Abigail, how you doing? Okay, great. Daniel, give me a thumbs up, would you? No? Did you push it out with the dowel? It should be hanging out at the other end. So if you go to the forward part of the airframe and try and hook it with the dowel, you might be able to get a loop and pull it out. How many rolls of tape did you put on it? Pull it out. There you go. All right. You got it now? All right. Jacob, Nick, you're good. Thank you. Everybody else? Pascal, UTTC, good? All right. Okay, let's refer yourself to the slide. It says here, tie a knot in the shock cord, a 1/3 total distance from the end of the slip knot. Okay, here's your slip knot. So what I want you to do, put your thumb through the slip knot, hold on to the other end like this, and right to the middle of your chest, like this. Drop the loop, let go of the loop. Keep your fingers on this part here. Okay, you got a loop right here. I want you to tie a knot there. Regular half, they call that a half square knot, they call that. Just like that. So you got a loop in there. Okay. I'll do that again.
Can you make the camera full screen? Cause I can't really see.
Sorry, just a sec.
Okay, I'll do it again here. Take your thumb, put it in one end of the loop, stretch it out to the middle of your chest. Drop the loop. Create another loop. Like this, about maybe 4 or 5 inches long, like this. And just tie a square knot, or a half square knot, they call it. Just like this. Yeah, just a simple square knot. Kind of tighten up. I do that knot again if you're confused. Same motion. Put your thumb in the loop, stretch it out. Drop the loop. Keep your fingers on this part here. Make a hook like this. Circle around, go underneath, in the rabbit hole, and back out again. How's that? Nick, how you doing? Oh, that's perfect, Nick. Anybody else? Jacob, looks good. William, excellent. Justin, good. Ladies, perfect. Okay, we're going to take our quick link and we're going to hook it on there. Not going to close it up yet. We're going to take our Nomex cloth shoot protector, and there should be a hole in there for you to hook onto the quick link. Let's close it up. For now. Okay, I want you to get your parachute out and unravel it. Don't mess it up too bad. And the chute should be in pretty good order right now. You want to make sure the canopy shrouds are pretty much equal to each other. You know, make sure there's not one like that's dropped down real low. Make sure they're pretty even or close to even. And then take your once you establish them being even, we're going to do the same type of knot that we just did a few seconds ago. We're going to grab the 4 shrouds, or 8 shrouds actually, lines. And we're going to tie another knot, another half knot. Try not to get the shroud lines tangled up. We're going to do another knot just like that, because that way, once you establish a knot, all the shroud lines will stay equal. It won't move on you. I'll do that one more time. Okay, once you have all your shroud lines equal to the canopy, keep your finger through the loop lines like that. There should be 8 of them. Tie another half knot. Bring all 8 shroud lines through in the rabbit hole and back out the rabbit hole. And if you have a little slack there, pull one of the shroud lines from the bottom And it should come out. And if it doesn't, I think it's this one here. Nope. There, one of them pulled through. Okay, you should have like a little loop like this, correct? Take your closed quick link that you closed up, open it back up, and hook your chute through that loop. And you should have a secured chute protector. And a next, pulling your parachute. The chute already kind of comes pretty pretty straight and folded in a sense. People have different techniques of pulling their parachutes, just like people have their way of pulling a shirt, rolling up a pair of pants, whatever. So what we do is make sure the shroud lines are spread out, and we kind of fold the chute in half several times to make a cone, as you see in the picture. Okay. And let's make another one. Probably got to fold it probably a good 5 times. So you make like a small cone of a chute, parachute. Okay, here's where the difference comes in people that pack chutes. Some people will take their shroud lines and make an S in their shroud line right there. Go to the next slide, Rob. As you see in the bottom picture, we were missing a picture, I think. Thought there was it showed a S pattern, one of the shots. But anyways, they keep the lines inside the chute like this. They fold it, and they'll fold it again.
It looks like it's doing it wrapped sort of outside.
Yeah, it does. A lot of people keep it inside. What I normally do, and it's worked a million times, and didn't matter what size chute I've used, I do the burrito wrap. Okay. You got the lines like this, and you have your chute in a burrito style, and this is not working out well at all.
I got a question.
Yes.
So I'm falling behind, but I got my 2 holes here. Where do I put this hole in?
I can't see you.
Give me a
Oh.
sec.
The parachute lines?
The parachute lines go in the quick link. Did you tie a knot on the end of it?
Yeah.
Shouldn't they
Okay.
be even?
Well, yeah, you have one shroud line that's loose.
Yeah, you
They
gotta
should
put
all be about the same lengths.
Yep.
So, like all 3 of those like those 3 or 4 loops should be the same distance.
Okay, so like this. And now just put in a quick link.
Is that with the second knot? I thought it was 2
Yeah, the
knots.
second.
Okay.
Pretty far. I mean, yeah, that works.
Okay, let's let me look at your knot, William. And put your thumb in between the loop. I want to see if you got them all even. Oh, they look even, don't they?
Yeah.
And take all of that loop that you have at the end of the knot
Yeah.
and hook it into the quick link.
Okay.
Just like that. Gonna end up like that. Okay, let's get back to the laundry. My routine was the burrito wrap. It wraps very tight. Shroud lines are even. And when you wrap the shroud lines around, don't go like this. Rotate your parachute, okay? And when you come around the first time, you crisscross the wrap on your shroud lines. That way, when it comes out, it won't get tangled up. If you do it with a wrap like that, they're going to crisscross and they're going to get tangled up and your chute might not open all the way. And like I showed you before, some people put the shroud lines inside the chute for some reason. They're hiding them. I don't know why, but these are very resilient. They will not burn. Of course, once you have your parachute in, your chute protector in there, it should not burn. So what we're going to do, take your rocket and booster. Well, mine won't stand up for some reason. And on this particular model, we take our recovery strap first. We'll usually put the dog barf in there first. When the motor is installed, that's just cellulose insulation. We call it dog barf because it looks like it when it gets wet. So we put our recovery strap inside the tube. We let it fall naturally like this. So when it gets deployed, it comes out almost the same way without any tangles. Then since this deployment reg is kind of the minimum size, usually they come bigger than this. We kind of put it on top of right in the center of the tube on the end like this. We take our parachute and we dip it in there just like that, just like a flower petal. And we're all done packing the parachute. Next, we take our last remaining quick link and we hook the other end of the recovery strap to our last remaining hook. And we take our quick link and hook it to the bulk plate of your sustainer. And screw it on, snug. Make sure you're not pinching any recovery strap inside the airframe. And you have a complete rocket ready to fly. Boom. Ready to rock. Any questions, anybody? How far are we going here? Everybody done? Everybody follow me? I can do it again. Let me see your rockets, everyone. I want to see your chute in there. I see Nick still has the pancake out on the table. And Daniel, he's good. No, he's not. What's up, Daniel?
I'm so stuck on tying the string on the parachute right now. I got my loop that's my even loops, but when we pull it through the shroud, that's where I'm stuck in tying it from there.
your parachute?
Yeah, I don't have it. St. Tide. I got stuck there. Trying to properly tie it.
Okay, do you have it going like this? Do you have a knot in it like this?
Yes.
Okay,
Get those.
you got your quick link that's hooked up to your chute protector?
Um.
And hook it like that,
Oh, okay.
and then tighten up your quick link.
Yep.
Got it?
Yes.
And the parachute again?
Yep.
Okay. The parachute's pretty much falls in place when you have it on the table, almost like in a pizza shape. I want you to fold it probably about 1, 2, 3, 4, 5 times. Okay. Like that.
Okay. Let me do this.
And some people will, like I say, will take their shroud lines and put them in a S pattern inside the chute. Like this. And I'm pulling everything off my table.
Yep.
And they'll cover it like this and roll it like that. I've had success just doing the burrito roll.
I'm so bad at this part.
Don't get hungry on me.
I'm gonna have to do this later. Look how much of a mess that is. That's horrible. That's horrendous. Yeah.
Okay, when you take your shroud lines, don't wrap it like this. Take your shroud lines and spin your burrito around the shroud lines and crisscross the lines. You have a crisscross pattern like that. That way they will not get tangled up. Because once it unfurls out of the rocket, it absolutely opens up positively. Roll it up, turn your parachute, and crisscross your shroud lines. Okay. Who brought this in there? Okay, once you establish that on the chute, drop your other end of your recovery cord inside your booster. Longest part, let it fall down into the tube. And then take your Nomex chute protector and your parachute. You put it on top of your tube like this, right in the center, and push it in. That'll protect it from the hot gases. Make sure you don't bind any of your recovery straps together between the coupler and the airframe. You're putting it together, okay? Any questions, anybody? Are we good? Happy rocket. Also, there's a little trick too. Once your rocket is all prepped and everything, things do happen as the rocket goes up. After the motor burns out, there's a inertia that happens to all parts in your rocket. As soon as the motor burns out, the recovery and the chute kind of go up into the rocket part. And if this is too loose, this will separate before you get to the top. So you gotta make sure that this has a nice snug fit. And usually the test, what I usually do is, if you hold it up like this from the sustainer section and the weight of the booster with the motor in it, and it's still hanging there, and you're shaking it like this, as long as it's not falling apart, but it's coming apart, you're good to go. As long as it's not dropping off, it won't separate after motor burnout. You're safe to go. Just remember that. And if it does drop out, what I do is we do a friction fit. We put the tape along the coupler to make it tight around the booster section, just to snug it up so it doesn't fall off after motor burnout.
What about this black piece?
Pardon me?
What about this black piece?
Oh, the
It's
black.
not even.
Okay, stand by.
Yeah.
I also don't think that we epoxied the bottom of the aft center ring.
No, not yet. That was my next question I was gonna ask. Because I think some people were doing it and some people didn't get to it. Your aft ring should get some epoxy. I think some of you did this already. Some epoxy between the aft ring and the inside of the airframe. We need some, make a nice fillet around that. Try not to get any epoxy inside the hole. You can just do it from the one screw to the next wood screw. This wood screw to that wood screw would be fine. Should be sufficient. Because the epoxy is holding on the back side of that anyways, and plus it's around the inside of that motor tube also. There. So once you put epoxy in it, you got to keep the rocket like in the up position like this, so the epoxy just stays in that one spot for at least a good 5 minutes, okay? Does everybody follow that? Can we move on to the next slide? Is that possible? As you can see on the slide, I have tape over those holes. I have the screws out, and it's not necessary to put the epoxy on the motor tube because there's plenty of epoxy holding that motor tube where it is, because this retainer sometimes interferes with that epoxy.
Right.
Ooh, certification. Okay, the certification process on this slide is pretty long and it repeats itself. AAA has a safety code, of course, the National Fire Protection Agency, 1127. That's why we get to fly high power rockets, because we send them up and they come back on a parachute. We have certain people that organize the launch. We have a prefect, of course. Our prefect's job is to organize all kinds of functions for the club. He can assign people to do other tasks like the range safety officer. His goal is to minimize the risk of personal and property damages involved in the handling and preparation and launch operations of model and high power rockets. That means he gets to inspect everybody's rockets. He's the guy that says no or go on every rocket. If there's something wrong with the rocket, you either fix it, or if you can't fix it, you can't fly it. The launch pad safety officer, we call them pad techs in our parts of the country. Launch pad safety, they got them labeled kind of weird. The LSO is responsible for determining the status of the range operation, site, airspace, and weather. He is usually the person that pushes the button. That's usually Bob. We do have double redundant system at our launch range where if Bob's not paying attention and he's doing something else, there's another person that has a kill button and deactivates the launch system if someone happens to be running into the launch range or the landing range in an unsafe area. All operations stop. The Launchpad manager, which I explained before, is a tech, we call them Launchpad tech people. They will assist you at the launch pads. They will walk out there with you with your rocket, and they will assist you mounting the rocket on the launch pad. They also will observe your behavior, your stamina, and your operation of your altimeters and make sure they operate correctly. If the pad tech says, well, that's not the sequence that I'm familiar with, or if you're not familiar with the sequence of the altimeters, he'll tell you to take your rocket down, deactivate it, and take your rocket down and take it back to the prep. Rocketry mentors. Rocketry mentors, there's TRA and NAR mentors. They got to be certified to the level equivalent, and we usually do level 2 people to be your mentors. They must be level 2. They may guide, direct, and assist you as you prepare for your rocket and go to the launch pad. Those are the people that usually will have your motor if you request it through that club. You are not supposed to own a motor if you're not certified to level 1. You can only handle the motor in the attempt of certifying level 1. Next, please. Oh, we got a launch failure picture, huh?
We could.
Yeah. I was there for this one. Need some sound.
Uh,
Did you check share audio by chance when you started screen sharing?
Give me a sec.
Go 300 to an Aerotech Show 280. Heads up flight. It's going in 5, 4, 3, 2, 1. Do not light. Do not light. Do not light.
Oh. That was a 2-stage rocket, and that was a very unstable rocket. And of course, the person called heads up because it was a 2-stage rocket. And that launches at Princeton, and they always have head up flights. Okay, launch site materials and supplies. When you come to the launch of any launch, even if you're going to certify at your home launch, it's a good thing to bring a drill of some type, screwdriver, some cellulose or insulation, considered dog barf, maybe some quick set epoxy in case you have to fix something. Masking tape is always a good thing to bring to the launch pad because you may need it to hold the igniter in. A couple of wood screws would be fine, washers, nuts and bolts, etc. Whatever you think you need. Okay, certification launch overview. When arriving at the launch site, you are expected to abide by the presiding organization safety procedure. Stay clear of people prepping rockets that you're not familiar with. Review the pre-launch checklist. You may be asked by the RSO, do you have a checklist? You can write one up, make one up, or look one up on the web. We do have them available here at Wisconsin Space Grant. And I think there's probably one on this slide, I bet. Complete the launch card that they will submit you. After the rocket recovery, return the rocket to the RSO or the person that was certifying you, that was observing the launch. Properly dispose of the rocket, take it home and throw it in the garbage. Sign and submit the TRA membership application to Frank Noble, Wisconsin only. That is if you're launching at our site. Otherwise, you'll have to do the same thing with the citing prefect or NAR member that observed your launch. They are the ones that turn in your membership and your certification papers. Pack the rocket for return home. Next. Okay, this is one of our standard launch paperwork. Launch card, I should say. When you arrive at the launch site on that day, you'll need to obtain one of these cards, probably from the registration table. Prepare your rocket for flight. Ensure that all your bonds, fillets are intact. I don't know what bonds are, but I didn't invest in any. Ensure all your parts fit. No excessive epoxy is undue to inhibit the operation of your rocket. Prepare your parachute as instructed in the workshop. And also, as a reminder, as you get your flight card, usually there's a launch fee at a lot of the outline launch clubs. They usually charge between $5 and $10 all day to fly. So be prepared to reach in your pocket for a flight fee. Next, please. Ensure your nose cones are attached, which we did with the screws. You may fly a payload if you wish, like if you want to throw a scientific or a altimeter inside the sustainer section. That's fine with me. Just don't let it have it rattling around. You can tape it to the inside of the payload section. Ensure that piece is taped. Ensure you have a piece of tape with you for friction fitting the igniter, which I mentioned before, and also your sustainer section to your booster in case it's loose. Prepare your motor. See the RSO or mentor for the motor. Ensure you have your motor retainer with you and tools to tighten it. Also, the RSO or mentor will ask you, well, what kind of delay do you want your motor in? And the delay is usually, I think, 12 or 14, 14 seconds is the maximum on a DMS motor, which is a disposable motor system. And we have tools to remove some of the propellant on the delay grain. Next, please. Fill out the launch card, put all the information as much as you can on it. Bring it to the LCO when you're ready to fly. The LCO will assign you a launch pad sometimes, or you can just walk out there and the launch pad manager will come back with the right launch pad number you are using. Proceed to the launch pad when the range is open, of course. Usually the launch pad or mentor will assist you with the launch prep. Make sure you are a member of either NAR or AAA before you even attempt to go to the launch pad. Insurance reasons, liability situations. Observe and recover your rocket. Return your rocket to the RSO for inspection, and he will sign it off if it's in flyable condition. Next. We're going to save this again. Oh, the NAR membership. He may ask you what the, you have to put the name of the manufacturer on the card. We're CG and CP is marked on the rocket itself. You can do that by looking at your rock sim for that particular rocket with that particular motor. All CG or all CPs and CG is all measured for a marginal stability with the rocket totally loaded. Parachute, motor inside, altimeters inside, whatever you plan to fly that day, it has to match that stability margin. Motor type manufacturer, type of recovery device. Motor manufacturer is usually written on the motor itself, so just transpose that to the flight card. Length and diameter and weight of the rocket. It's a good idea to put your weight, length, and your phone number on the coupler of the rocket, or even your name. Your cell number would be cool in case you can't find your rocket, someone else finds it. There it is. I'm gonna call Rob up. Predicted altitude, of course, and remember to conduct a simulation in RockSim. Usually the RSO or NAR will not ask you for that, but you can have that information in your head or have it written down. This is what I simulated. Next. Okay, pre-launch operation preparation. Okay, the airframe must be built by the flyer. Actually, the whole rocket must be built by the flyer. Display the center of pressure recovery. You just went through that. Standard parachute recovery is required. What size chute is on the rocket? Single certified H or I motor. Total impulse of the motor, which should say on the motor itself on the carton. And let's see, we'll go back to B here. Flyer shall be observed by the certifying member during the assembly and preparation of the motor. He will watch you. I think I explained this before. All electronics, and of course, electronics are not required in a certification level 1. Next, please. Okay, obtain a motor from the RSO or a certified person that is designated to handle a motor. You call up Joe and say, hey, can you get me a H100? Oh, sure. When you coming? Well, I'm going to come next month. Okay. Providing the weather is good. Of course, Wisconsin Space Grant will provide you the payment of just a level certification motor, just one motor. Obtain the motor from the RSO or representative. Perform your own motor prep. Remove the certification motor from the protective cardboard tube. And the motor is encased in a static bag. Remove the motor from the static bag. Plus you have a little packet like this. This is real important. Keep this packet with you. It's got the igniter in it. It's got the black powder. It has a baffle washer in it and a plug and the igniter. The RSO will observe your motor prep. It is not a test. It is a hands-on learning experience. If you don't understand something, ask the question to the RSO person. Insert the motor in the rocket and install the motor retainer. Did someone ask me about that? And I shall do that for you. Take your motor once it's prepped with the black powder in it. And we'll go through that in a little bit. This is kind of out of order. Insert your motor inside your rocket motor tube. Remove your number 8 wood screws. Will one do it for me? Yeah. And insert your motor retention system. Install your number 8 wood screws and snug it down onto the half centering ring. That should keep it right in there. And my habit is of keeping the igniter secure. And I shall get a fake one here for you. Let's say this is an igniter. Okay, and this is actually a charge, but we're not going to deal with that. A good safe place is to go to the launch pad, of course, with tape. And you don't have to take the whole roll. You can just put it right on yourself. You only need like a couple pieces of tape. Take it up there with you, put it on your shirt, or take the whole roll up. And take your igniter and tape it in between the fins, okay? The igniter isn't as big as what you see here, but if you tape it in between the fins, Nothing will bother it, even if you lay the rocket down. These igniters, they have a little cardboard tube in them. That's just for shipping because the pyrogen is almost that long and it's kind of brittle in a way. So they put this cardboard tube on it to protect it during shipping. You pull that cardboard tube off when you're ready to insert it inside the rocket. Turn it on. Next slide, please. Oh, those are all the intricate parts for your rocket for ignition. You have the black powder. Excuse me. You have the black powder, which is in this pack. Cut open the pack. And you have a little, excuse me, a little baffle right here that goes into the ejection charge well or crucible, whatever you want to call it. And it goes inside here, flat, just like that. That adds a little punch to get the black powder a good charge to get out and push everything out. And you get a little vial of black powder here. Comes in a little case like this. You just kind of crack it open like that. And that's about 1.5 grams of black powder. They usually give you, sorry. And you take this and you pour it in carefully. Pour about half of it in there. And take your motor and kind of tap it like that so it falls through that little hole. Because at the end of that hole is where the deployment fuse is. It's not a fuse. It's a slug of propellant that burns real slow. It's a certified motor, and they are all timed within 10% of the time that's they say on the label. And
That's
then
the delay grain you talked about earlier.
and just kind of tap it in there, and the black powder will fall and touch that grain of that slow burning propellant, because the motor burns from the top down because you have your igniter all the way to the top here. Everything lights at the same time, the motor and the time delay. The time delay burns real slow for 14 seconds, they claim, plus or minus 14, the 14 seconds. And as the motor burns, the propellant in here burns real slow, and the rocket gets the apogee and poof, blows, ignites the black powder, and parachute comes up. Okay, after you've shaken that black powder, pour the whole vial of black powder in there. Take your cap like this, it goes the opposite way, smooth side down, put it down. And I have a habit of putting masking tape over it because on cold days, this will shrink or expand or whatever. It may come loose after the motor heats up. So I put tape on here so it stays on. Next slide, please.
And that red cap's fallen out on me before, so I always have that.
Right? Yeah, it's not foolproof, that's for sure. I don't have the tool with me. It's locked up right now. That's the delay tool that we use. It's gauged with a washer and the size of the drill bit that you turn. You do that before what I just did here. You put it in the top here. These slides are kind of out of order. You put it in the top here and you twist it. You can take off 1 second, 2 seconds, 3 seconds, whatever the gauge you set on that tool right there. And what has worked out was probably a good 10 seconds to 12 seconds, 10 to 11 seconds has worked out pretty good. I usually add that extra second or half a second more than what the RockSim says, and it seems to work out pretty good. And of course, as you're twisting that out, you should tip it upside down and get that slow delay propellant out of there. Okay, then you can load your baffle and your black powder and your cap. Okay, next. We did that. Next. Certification prep. Insert your motor. We inserted that thing so many times in the last slides. Attach the motor retention system. We did that. Secure the igniter with tape. What we do is, this is the pyrogen. This is the black stuff that gets hot and it ignites the motor. Okay, and we ignite it electronically. So we have leads that we put in. This igniter has to go into the throat of that motor and all the way down till it stops. Okay, put it in the center. I'm not going to put that in there right now because that's a no-no. But you know, I could put the other end in, and you put it in, and it doesn't go in very far.
At the launch pad.
Yes, you do this at the launch pad. You do not do this at the prep. You do all the pyrotechnic stuff at the launch pad, except for the prep of the motor or the black powder that you do at the prep table. But do not put any igniter in the motor at your prep. You do it at the launch pad once the rocket is in the vertical position. And once you have the igniter all the way up in the top of the motor, we usually put some tape on it to hold it in securely. All right. And we have 2 leads on the end of this that you should have already prepped at the prep table, these wires right here. Because it might be cold out there when you're doing this, and you might be with other people. So you got to skin the wire off. Like that. You got 2 bare wires right here, and that's where the 2 alligator clips go at the launch pad hooked up. But you can do this at your prep table, but do not put the igniter inside the motor. You can prepare this igniter, twist the 2 bare wires together to shunt the igniter. Wrap it up like this, put some tape on it, and tape it to the side of your rocket in between the fins. You're all set to go. All you have to do is put it in and tape it up. Next, please. We did that already. We did how you fold a parachute. We did that already. Yep. That's good. I suppose we got to discuss different types of payloads and locator devices for your rocket. Tripoli, Wisconsin only. Additional recovery techniques are used for certification flights when flying in adverse conditions, like if it's windy out and you have a 36-inch parachute in this level 1 rocket, you can choke up the chutes so it doesn't drift very far, or you can use that little Jolly Logic altimeter right there. That Jolly Logic there, I think the minimum is 200 feet that it will deploy a parachute. So what that device does is it's a device that sits on the outside of this chute protector with your chute in it, and it has a rubber band that goes around and hooks onto the altimeter like that. You can see on the right hand side, very small little solenoid pin. That pin goes into the solenoid, and this holds everything together. And as the rocket gets to apogee, everything comes out, but this is floating in the air with the altimeter strapped to it. So whatever altitude you have that set at, the rubber band and the solenoid will open up, and your chute will open up at a certain altitude. It's a pretty neat little device. They work okay, but on operation of it takes a little experience, because if it's too loose, it won't release. If it's too tight, it won't release. So let's say you have a tightness between one, you got a tightness gauge between 1 and 10. The tightness has to be between like 4 and 8 of the tension to operate properly. So it takes a little bit to get used to how that should be adjusted for the tightness of the rubber band going around the chute, because sometimes you might have a smaller chute, you might have a bigger chute. If you got a smaller chute, you might have to change that rubber band out because they give you different lengths of rubber bands for the tightness. Yeah. Okay. Streamer recovery or tumble recovery from apogee is possible from apogee only, but you must deploy a parachute before it hits the ground. We have RF trackers. It has antenna. Yagi antenna works good. This device will locate your rocket, but don't always depend on locators. Always watch where your rocket lands. Then you know what direction to walk in with the RF finder, because sometimes you won't get communication. Sometimes trees will block it, ditches will block the location of it. So if you know what direction your rocket landed in, walk that way. Sooner or later, you'll pick up the signal. Next, please. Certification prep again. These devices are not required for certification flight. If the plan to use devices in a familiar operation prior to flight, ensure that the mentor or RSO is aware of any devices used in the flight. Jolly Logic or what's an RC plane? Oh, device. Okay. Next, please. That's a little far-fetched for level 1. Once you are prepared for your rocket again for certification launch and have completed the pre-launch checklist, check with the LCO for the pad assignment, turn in the launch card again, proceed to the launch pad when the range is open. If you're not sure if the range is open, ask the LCO. Ask him or her, is the launch pad open? Launch pad manager, of course, will assist you at the launch pad. He will tilt the rod or the rail down for you, and you install your rocket onto the launch pad very carefully. Your rocket should be on top and your rail buttons down. Slide all the way down until it hits the stops on our systems. Most of our stops are on the rail button. We have something through the rod that's rests on the rail button. Okay, next slide. Carefully observe the descent of your rocket for retrieval, as I mentioned before. Always look for landmarks. Look behind you, look in front of you. Draw a line with your foot on the dirt in the direction that it fell down. Take a buddy with you. If you want to go out in pairs and assist each other, it's always safe to do that. Look for one another and then the other. Do not enter any hazardous situations like water, thorny bushes. Just walk around it, but keep your mark on where you're going to be recovering your rocket. Do not, of course, enter trees, climb trees. Check in whenever the search is for a while. Well, the LCO or RSO may ask for your phone number in case you're gone too long. So we have to send out a rescue team, or we can call you and say, hey, what's going on? Did you find your rocket yet? Usually somebody at the launch site might have saw where your rocket landed and he'll give you a hint. And always remember, a rocket usually lands a lot farther than you think it did. Next, please. This is the bog recreational area. Note the hazards. We have water conditions. We have marshes. We have little ponds. That's all you got. You got to keep your head on a swivel. Next, please. Of course, the RSO will inspect your certification of your rocket, see if there's any damage. Your rocket must be flyable. If you have a little minor damages on it, like you can fix it like in a couple minutes or band-aid it up, that may go, depends on the RSO's mood that day. Of course, your membership is only valid for 1 year. You must re-up it annually. They will send you an email saying, hey, you need to re-up your membership to stay in status quo with our organization. Otherwise, you cannot fly at a sanctioned insured launch venue. Next, please. Oh, of course, Wisconsin Space Grant, of course, pays for your only level 1 flight motor. That's it. They will not, if you want to do your level 2, they will not supply the motor either if you attend a venue in a year or two. We will supply a test for you for level 2, but Wisconsin Space Grant will not provide the motor. Okay, any of the following results is a non-certification. A CATO, which is catastrophic takeoff. That means that the motor failed. The airframe has failed for some reason also. Excessive damage to your rocket. No recovery system deployed, or the chute got tangled up during deployment. Rocket drifts outside the specified launch range. We have almost a 2,000-foot launch range. It's usually a highway and the end of a farmer's field. If it's outside that area, you are not supposed to be certified. But if you come back with the rocket, you don't have to tell us. Rocket components coming down, not attached to the recovery system, like you have a separation, we call it. It's when the one of the systems on the rocket fails, like a bulk plate breaks off, or you forgot to hook up your quick link to the parachute. Any other violation of TRA safety code associated with this particular flight. Any other legitimate reasons the certified member deems merits and not certified. Next, please. Yeah, we went through this already. Of course, dispose the motor when you're done with it. Take it home. You can keep it as a souvenir. It's non-flammable anymore. Some people like the way it smells. During the competition, transporting the rocket from Kenosha, you can do it in a checked bag flights, or ship it from the hotel. Boxes and bubble wrap and labels will be available for shipping for certification launches conducted at Richard Vaughn Recreational during launch weekend. If you ship your rocket to the hotel during the competition weekend, keep the original package material for return shipments. And let me tell you, it's not very cheap. Next, please.
It's a little pricey, and I will make sure to have some guidance come out. I sent out a message in the chat, just sort of polling the group in case you guys had an idea already if you were going to be doing your cert launch locally to you, or if you were going to bring your rocket with you on launch weekend. We should be able to accommodate. We've been able to in the past. It is a full year, but the Tripoli team is absolutely amazing at how many rockets they can get off in a day. So it shouldn't be a problem if you guys did want to bring them with.
That reminds me, Rob. This year, our organization did an event in July called LDRS. It's called Large and Dangerous Rocket Ships. It's an annual TRA event that's held throughout the United States at different areas, and we were one of them. And we flew over 500 rockets in 4 days. So, of course, the weather was beautiful all 4 days.
Yeah, we're hoping for no mini monsoons with us this year.
Right.
When you do your initiator. This is Gorman, ready to.
Then we have this video on that page. You guys want to watch through?
Launch my first rocket. Okay, this is Gorman. My first rocket. I've now put on the clips. Clips are there. Got rocket engines there. Look at that. One. So Forget stuff. this is Paul. This is my, what is it, SRO or NRO? What do you call it? RSO. RSO. There we go. Range Safety Officer. You want to wait for those guys to come in? Yes. Yeah, I think you should. Yeah. Rockets okay?
Okay, next up, we got Gorman Cook here. This is a level 1 flight. This is the first flight. So, he's flying this. It's a giant leap. Liberty 4 on the H400 VMAX. Regular chute recovery, expected altitude 1200 feet.
Could be something else, but that's my
We're
bet.
flying
Okay,
on
I'm looking.
pad
Sorry.
E1. We have continuity. Going in 5, 4, 3, 2, 1.
Beautiful.
Nice flight.
There you go. All right. Nice. You can see that was a good motor choice. All right. That was a VMAX. Okay. H400.
I hear Bob.
Now, having watched that, do you think it could get up on an H125?
No, I don't.
Okay.
Not unless it was windless. In this wind, I think you would have come over quite a bit at those fins. And... You got the gizmo? Oh, I mean, the minivan. I-180 just like the, That's a pretty heavy rocket, though, isn't it? The one that just flew?
Next,
Yeah, it was 6 pounds empty.
Okay. That was a NAR launch. Certification required, NAR launch, level 1 certification, Richard Bong. That's what it was. Yep. Next, please. Okay, workshop closing review. We got questions. Where can a rocket supply equipment files be downloaded from? Supply equipment?
What was the website that Aaron brought up and suggested for finding extra motors or parts?
It's gonna be worded different.
I think it meant the rocks and files, I think.
Right. Yeah, not rocket supply equipment.
It was it. The answer I have leads to rocketreviews.com.
Really? Well, that's gonna be a different question because I didn't get it.
No, yeah, you download rocks and files from Rocket Reviews.
All right, next. What checkbox is critical to check or uncheck in RockSim?
This is that system level thing I mentioned a couple times. Anyone remember?
Regarding weights.
Is it mass override?
Yes.
Yep. That one I got.
Check this.
All right, next. What's the key enemy of any rocket build? Sort of ties in with the last question. Lighter rockets can go higher. All right. We'll go with weight. All right. What does an altimeter do? Oh, come on, guys. I know we're all exhausted. We are almost there, I promise. Like 2 slides left.
It tracks where your rocket is and the exact locations of it.
Close.
It tracks the height of the rocket.
Yep.
But
It measures the altitude of your rocket. Also, it can function as a electronic device to deploy your recovery device also.
The location one is a tracker.
Yep.
Right. And then what is a reasonable rocket descent rate? What are we looking for with the parachutes? Where are we trying to bring that down to?
Isn't it 30 meters per second?
30 something.
Is it 30 feet per second?
30 feet, yes.
Right. And then in order to become level 1 certified, what must you do?
Build your own rocket for one.
Build, launch, and recover. It needs to be recovered safely. That's the important thing. If you can't find the rocket, then we have no proof. I've seen a few certification launches that the rocket ends up being gone forever, even though it was bright pink and bedazzled. Still lost it. That was not mine. All right. And then who are the key personnel that you'll be working with at a rocket launch?
Frank Noble.
Answer.
Very good.
Usually,
I know,
usually the RSO or the mentor.
Yep. RSO, launch control officer, launch pad manager, all key roles. But if you see Frank there, it's the easiest way. All right. So, quite a day and a half, right? So you guys have gotten through all the core principles. Of course, it's not a full-blown college class over a semester, but you know, quick and dirty, gives you all the basics of our rockets. So you have your level 1s in front of you. Now you guys, as soon as you do the cert flights, you work on level 2s. So everyone feel comfortable with, a little more comfortable with rock sim now? And a little more confident in being able to work on your competition rockets now that you've gone through the basic principles of how to make sure these things stick together. All right. And this will be a good point. So with the certification launches, I know we had a couple responses in the chat. So if you haven't answered already, we just need to sort of get a gauge on, sorry, trying to find it in the chat.
There's a lot of
So if you're planning on doing your certification launch locally, or if you're planning on coming to launch with us in April, and then if you're going to be launching locally, what expected date you're aiming for, if you guys have been looking at launch schedules, and then who are you to be flying with? You know, who is the certifying mentor that you'll be working with, or the precinct? We would need to have sort of a name, that way we can have the motor ship to them, because you guys would not have your certification levels yet to be able to receive a motor. So very important stuff that we would need if you're going to be launching locally to yourself.
Yeah.
And you don't have to know that today, but it is definitely information that we will need soon. It just helps with planning, of course. But if you can email that to Connie and myself, then I think next one.
And Rob, you're setting up a follow-up email with that information that they can go off of, right?
Yes.
Okay. So there will be a post email with follow-up info.
So it'll include all of that. It'll also include I'm sending out this link in the chat. It'll also be in that email as well. The sooner you fill it out, it just while the information, the workshop is fresh in your minds.
Yeah, get it over with.
End the pain.
Yep.
It should be a relatively quick questionnaire. I haven't checked it recently, but it's generally we just want to know what did you like about the workshop, what worked, what didn't work, things like that. Don't worry, you won't hurt my feelings.
We understand it's quite long and at some points, but we give it a full-blown rocket build and information, probably more than what a TMP, which is a Tripoli mentoring program that we do for people that are between the age of 12 and 17. They can certify level 1 if they want. And this is a little more grueling than that. All they have is a 30-question exam, but you don't have to do it in one day either.
Oh, any questions back for us? You're welcome to ask them in the open forum. You're, of course, if you feel uncomfortable with anything, you can always just email us. But
I have a question about the mentor. So for Haskell, we don't have a mentor at the moment. Is that something we get after we go to like the place that will certify us?
that one, it's more so if you're going to be certifying near yourselves, we would need to know a contact of who you're going to be working with, like who is the RSO for that, because we wouldn't be able to ship the motors to you. You guys don't have the appropriate certification level just yet.
Okay.
That's where we would need to, if you guys know what launch site you want to use, if you have like the frank of that field, we could always try to coordinate that.
Right.
Okay.
You don't need a mentor to go certify level 1, but it is strongly suggested, since you have not been in this high power venue for till today. Most people that do go and try to certify level 1, they usually attend the launch probably 2 or 3 times and fly small rockets before they attempt a level 1 and get into the know. So we would like you to actually try to reach out to a mentor, and like Rob said, contact us and we'll see if we can talk to the launch organizer that you are attending the launch with.
Okay. All right. Thank you.
Yep.
Also, you are required as a team to have a mentor. You guys had down David Sicilian, but I think somebody emailed me that he doesn't have the right certification to do that. So oftentimes Mark Abatasaway can help you try to find a mentor for your team as a whole, and that person might help you figure out where you're going to launch for your certification.
Okay. Thank you.
I know you guys are all anxious to leave, but any other last go backs? If not, thank you all, and we will be in touch.
Thank you.
Very quick. You finished 45 minutes early.
It was a great workshop. Thank